Hi everyone, welcome back to my channel. So today I want to cover certain SQL questions, right, that are being asked, and similar type of questions are asked in Amazon interview. If you are attending the interview for BIE role like business intelligence engineer or senior business intelligence engineer or data engineers, right? Typically, in the first round of the interview, they will try and check your SQL concepts, right? I mean, whether you can write the queries, you have worked in SQL or not. So they try and cover certain fundamentals of the SQL, such as rank function, which is called like uh, also the Windows function, whether you know group by, right? All those things, joins, etc., etc. So I have certain uh, I want to cover certain concepts with the three queries that you see. So let's look at two of the tables, right, that we have. This first table is basically a select star from movies. This movie table contains the movie ID, the actor ID, the director ID, and the release date of the movie. So there's various combination, right? The movie M1 can have two actors, right? So Tom Cruise, Brad Pitt, director is Steven Spielberg for that movie, and then the release date is 1st January in 2019. Same way Christopher Nolan has the M4 and M5. The actor is George Clooney and things like that. So it's basically a sample data set. Then there is a movie type. So if you see the movie type table, there are three movie types. So basically what this says is what is the type of the movie, right? So the movie M1 is action movie, M2 is romance, M3 is comedy. If you observe here, right, they did not give a type of the movie for M4, M5, M6, M7, and M8 because there's a question coming up like question 3. So basically they probably want to trick you, right? I mean, just test your knowledge, right, whether you know all the joint conditions or not. So it's purposely being data is purposely being stored like this. So the first query that they are saying is write a query to list the actor director pair who have worked on more than two movies together. So if you see this table, right, then if you see, so list the actor director pair. So you need to list actor and director pair who have worked more than two movies together. So if you see this pair, right? So if you see Tom Cruise and Steven Spielberg, they have worked on M1 and M2, right? So more than two movies. So they have to work on three movies, right? So just read the. You need to be very careful, right? I mean, when you write a query, you need to read each the proper sentence because they try and trick you. Worked on more than two movies together. They're not saying more than or equal to. They're saying more than two movies. So we need to find three movies, right? Whether Tom Cruise, so if you see it's Tom Cruise and Steven Spielberg have done three movies, M1, M2, and M3. So that data, right? I mean, you just need to find that kind of a data set where they have done three movies together, right? I mean, actor and director. So here the knowledge that they are trying to test is basically a group by, whether you know group by or you know having and things like that. So if you see this query, right, so first of all they are asking you to list a pair, right? So you need to put actor and director ID. After that you need to take a count, right? Because if you don't take a count, how will you determine that how many movies they've done together, right? So if you see group by, right, so what group by will do is it will take a unique pair of actor and director ID, right? And then it will do a count. So basically if they said just actor, you don't need a director in that pair, but since they have said a pair, we need to put actor and director ID. And then you can having is the clause, right? So one of the questions that can come up in the interview is like, what is the difference between where and having? So having basically goes with the count. So you need to have a group by. So having goes with group by. Having is also one kind of filter condition, but you can't just put having, from movies, having like that you cannot put. You need to have a group by. So group by and having goes together, whereas where clause doesn't need group by. You can just put where actor ID is equal to Tom Cruise, and it will give you all the data, all the movies which Tom Cruise has done, right? So it's a simple where condition, filter condition. So if you run this query, right, what happens is you will see that data. So let's execute this query. So here if you see Brad Pitt and Steven Spielberg have done three movies together. Tom Cruise and Steven Spielberg have done 3 movies together. So there is only these two combinations. George Clooney has also done movies with Christopher Nolan and Steven Spielberg, but the movie count is not greater than two. Maybe two, but not greater than two. So that's your answer. So it's just that look at the read the entire sentence, I would say, and then try and come out with the framework, right? So when they are saying list the actor and director, just check actor and director is in which table. Is it a movies type or is it movies? So it is in movies, right? And then do you need to go to movies type, like do you need to make a join? In this case, no, right? Because they are not talking about the type of the movie, right? They are just talking about the actor and director pair. So you don't need to, you will just need one table, right? So just try and structure this in your mind, like what is being asked for, and then read the sentences carefully. Work for more than two movies together. So when it comes together, right, probably it's a hint that you need to use group by clause, because when one or more person, right, more than one person or more than one column is being asked, usually the group by clause is being used, right? So that's your answer for work question. The second question is list the actor each director has done the most movies with in each year. This is little tricky, okay? I mean, this needs a skill of subquery and rank. So rank is one kind of a Windows function, right? So you need to learn the different functions such as rank, dense rank, row number, and I'll cover all those things in a separate video, right? All those Windows function. But just for the sake of this video, let's just see what is being asked, right? So list the actor each director has done the most movies together. Most means they are asking for you to list the highest, right? Highest movie. So if you see Steven Spielberg and Brad Pitt, right? Steven Spielberg has done with Brad Pitt 3 movies. He has done with Tom Cruise also. But remember, it's saying each director. He is not saying like just only Steven Spielberg. He's saying that each director. So if you had, so in this table, just to simplify it, we have just two directors, right? Steven Spielberg uh, and uh, and Christopher Nolan. But you can have multiple directors, right? So for each director, they want to know, right? So basically, it's telling you that you need to partition by director, right? Because they want it by director and each year also. See, most movie means count of movies within each year. So for example, they need partition by director and for each year also. If you look at our table, it has, if you see, the release date is 2019. It is not having 2020, right? So you don't need to worry about this year part. But if they had 2020, you have to worry about that as well, because in each year they want to know, right? So but for this particular example, it's just 1 year, so you don't need to worry about that piece of it. But still you need to put year, so that even if you had 2020, this query should take care of it, right? Because it's automated, right? So it will take care of it, right? So first of all, what need to do is they are saying list the actor each director has done. So again, they have asked a combination of actor and director. You need to put year, right, within each year. So what you need to do is in SQL Server, there is a function called year. So what it will do is in release date, it will just take a year part. If they have asked month, you can take month of release date, right? But here they have asked year, so put as year. Rank. Now rank over partition. So rank function is a window function which goes with the over partition by. Okay, so with rank you can do over partition by. So what you're trying to say is rank is basically, as a self-explanatory, rank is saying rank this data, right? Rank this data into 1, 2, 3, 4, 5, 6, right? Ranking, right? So the rank function is there which will rank, because we need to find the most movies, right? So we will have to rank it, right? Like Steven Spielberg has done with Tom Cruise how many movies, with Brad Pitt has done how many, with George Clooney has done how many, right? So we need to rank each of those combination. So in this case, over partition by director ID. Why director ID? Because they are saying each director they want to know, right? And then you need to order by count, right? And descending. Why? Because they are asking for the most movie, right? And descending means if you don't put descending, it's going to do ascending. So it will start with the list, but we want the descending. So we want to rank the number of movies by the most movies. If here they had a list movies, let's say has done list movies, then you would do ascending here. Okay, you will do ascending here, because if they're saying list, that means you need to start with the lowest. But if they're saying most, that means you need to start with the highest. So in that case, what you will do is In that case, you will do descending count of movie ID, right? Because they are asking you to basically count each of them, right, as a rank number. From movies, group by, again group by will come. So first of all, this is the subquery, right? Because there's a query within the query. So if you execute this one, you can see that it is giving a rank to each of them, right? So for example, Brad Pitt and Christopher Nolan has done the highest number of movies. Brad Pitt, George Clooney and Christopher Nolan also has done the highest number of movies. Why? Because both of, if you see the data, both of them have done 3 movies together. So if you see the data, right, if you see the data, the George Clooney and Christopher Nolan, if you see 2 movies. Steven Spielberg with Tom Cruise, 3 movies we saw that. Steven Spielberg with Brad Pitt, 2, 3. See here also 3. Steven Spielberg with Brad Pitt is 3, right? So what happens is, over here, if we run this query again, what happens is, with Brad Pitt, if you see Steven Spielberg, right, and see this, the rank started with 1, 1, 3, 3. We'll come to why 3, 3 is there. But if you see Steven Spielberg, it started with 1 again. Why? Because we have put over partition by director ID. We want to partition by director ID, right? That's why we have put a director ID here, right? That's why it's starting with 1. So if you see, Brad Pitt done 3 with Steven Spielberg. Tom Cruise also done Steven with 3. So that's why it is ranking both of them, right? Which is correct, because if it is equal number of movies, both has to be listed. This is where they'll trick you, right? It's not just Steven Spielberg, Tom Cruise 3, Brad Pitt, Steven Spielberg 2, not like that. So they want basically you to use RAND function. They want tested knowledge. So what happens in case of RAND function is, in the RAND function, right, what it'll do is basically, if it finds a matching of the 2 records, it'll skip the next one. So it has skipped 2. Now it is directly 3. And I'll cover this in another video. So if you use dense rank function, right, I think there is some other function for the SQL server. There is a dense rank function in Postgres that I know, but there is a dense rank. What it will do is, it will do first 1, 2, and 3. You know, it will do 1, 2, and properly assign it. So sorry, in case of dense rank, what it will do, it will still do 1 and 1, but here it will not skip the rank. It will do 2. So if they said how many has done the most number of movies, give me first two ranks, right? They'll say most movies and second most movies. If they say that, then you can't use rank number, you can't use rank, you need to use rank, because you don't need to skip, right? You don't need to skip the rank. But in this case, it's most movies, so we don't need to worry about like what is being next rank, right? So if you see, the rank is 1. Similarly, Christopher Nolan has done same number of movies with George and Brad. So that's why you see 3. And here also, if you see 3, because these Leo Caprio and Will Smith also have done the same number of movies with the Christopher Nolan. So that's why it's 3, 3. So what you need to do is, you need to write this as a subquery. Then they are asking actor and director, right? So, and then year, right? So where b dot rank number is equal to 1. So if you do that, what will be the answer? This is the answer that we are looking for. So Brad Pitt, Christopher Nolan, year 2019. George Clooney, Christopher Nolan, 2019. Tom Cruise and Steven Spielberg, Brad Pitt and Steven Spielberg. So they have done 3 movies together. They have done 2 movies together. So it's a correct answer, right? If George Clooney has done 2 movies with Christopher Nolan, his name would not come, because it will be assigned as a rank 2. Correct? That's why, that will not come up over here. Okay. So if you see here, what is the concept being covered? The Windows function, rank over partition by, and then subquery concept, right? It's not a simple straightforward query like this. You have to write a subquery for this, right? So that's why this is the second query. Okay, that's the answer. Third query is, list the movies which has either action movies, which are basically either action movies, or which does not have any types associated with. So if you see, right, are either action movies action movies. So when they say action movies, you need it needs to click you that the movie action, where is the type stored? It's stored in the movies type table. So you'll have to join these two tables, right? And then if you see which does not have any types associated, or movies which does not have any types associated to it. So remember I told you, like, there are M5, M4, M5, M6 movies which are not in this table. So that's the reason why they have purposely not given this. So if you see M4, M5, M6, there are movies, right? But in this one, you basically, you will not get that data, right? So if you see here, you are not getting that. So when they either action movies or which does not have any types associated with that, make sure that it's a filter thing, right? So in this case, you have to join two tables. So, but there are different kind of joins, right? So if you just do a simple inner join, what will happen is the data will not come up, because they are saying that give me an action movie. So for that, if the inner join will work, but they want a movie also where movie ID is not in this particular table, right? This particular table. So they want M4, M5, M6 also. So here what happens is when you do a left join of movie, okay, and with movie type, right, on movie ID is a common column, right? And you need to write where basically, right, where b dot type is equal to action, or a dot movie ID not in movies type, right? Because movie type, because the movie ID A4, A5, A6 does not exist in this table, right? So you need to get all those movie IDs, right? That's basically what they are asking for. So if you see, M1 movie is the action movie, right, as you saw in the table. M2, M3 has not come up because if you see this, M2, M3 are romance and comedy, right? And they do exist in the movies type table also. So they should not come up because they have said only action movies, or which is not there in this. So M2, M3 is there in this, right? So it should not come up. M4, M5, M6, M7, those are not there. M8 also. So that's why it should come up, right? So if you see this, M1, M4, M5, M6, M7, M8, right? So it's a correct answer. So with this, they are trying to test your knowledge again of the subquery, filtering, and the join conditions, right? So inner join, outer join, left outer join, right outer join. So I'll cover that also in my next video or upcoming videos, right? So to see like what are the different kind of joins, and I'll explain with the practical example like I explained in this video. So I think you just need to just brush up your concepts, right? I mean, you can take this example, right? Create a table just like what I have, right? The movies table, right? You can just create this particular table, right? It has just 4 columns, and then you can write your own query with different scenarios, right? And then try and practice different things. Like I said, dense rank, right? Try dense rank, try row number, what happens, right? So basically in Amazon questions, they will test your knowledge on subqueries, they'll test your knowledge on group by having, they'll test your knowledge on Windows function like rank, dense rank, etc, etc. I hope this video was helpful to you guys. Please subscribe to my channel and like my videos if you feel that this was very helpful to you, right? So that will encourage me to make more of these videos with a lot of practical examples. So that's it for it today, guys. Thank you so much.
Welcome to my channel. Today I'm going to go through the interview questions that are asked in a SQL interview of Amazon. I already made the part 1, and that is I published that a week ago, and this is the part 2 of the series. If you look at my tool that I'm showing, I'm using Postgres as a database on the Postgres as a database, and going forward I'll be doing videos on the Postgres database. It is very easy to download the Postgres from the web. The tool is available free, At the end of the video, I'll cover that how can you download the Postgres, or I'll just give a link in the description, and then from there you can just simply download the Postgres on your Mac or on your Windows. So let's get started. I'll probably, and one thing I kind of thought of, like, right, I mean, I'll probably write the query along with when we see this queries, we can just along with the questions, I can write the query so that you guys can also understand, right, I mean, how the what is the flow of the query, why we use certain functions, and then I'll also touch upon the concepts that are used, right? I mean, so Amazon tries to touch upon the concepts such as rank function, row number function, those are called Windows function, and then group by, where clause. So I'll probably be making more videos on differences between where and group by and things like that, the concepts of the SQL. But for this video, let's get started. So there are three tables that are being given to us. So first table is select star from customer. So customer table. Pretty straightforward customer table, right? So you have customer 1 2 3 4 5 6, customer 7, their customer name, customer cities, the customer date of birth, and then customer pin code. The second table is customer territory. So in that, again, customer ID is there, right? So just we need to just that customer ID can be joined with a customer table to get the territory, right? So territory ID, if you see, these are basically the states: the Arizona, California, Utah, Ohio, right? And then customer city, the Atlanta, San Jose, Austin, and customer pin code. And then map employee territory. So the employee territory is there. So if you see the common column between customer territory and map employee territory is territory ID, right? One is basically customer territory where customer resides. The second one is the employee territory where employee resides, and then product subcategory of the employee. So these are the three tables. So first query that they are asking us is write a query to display those customer names and their occurrences when the customer name appears more than once. So basically what they are asking is display the customer names and the number of times those customer are there in the table, right? And there where it is occurring more than once. So here, you just need to be a little bit careful while looking at the question, because if you look at this question, right, they try to trick us. Like how? So they are saying those customer names, okay, they are not saying customer ID. So what will come into your mind first thing? Customer ID. But no, if you see, customer ID is unique, right? It's a primary key. So if you see 1 2 3 4 5 6, right, if you do a count, the customer is going to appear only once, so all customer will show up, but they are saying customer names. So if you see customer names, customer name number 1 is Lindy, 2 is Madison, 3 is Kiara, 4th is Beth, 5th is Beth, 6th is Beth. So if you see, Beth name is appearing 3 times, and then Lindy's name is appearing 2 times. So in this case, what should be our answer? Our answer should be Beth and Lindy, because Kiara and Madison are appearing only once, right? So Beth should be 3 times, Lindy should be 2 times. So let's get started. So here let's select the columns, right? So what we want to do is they want us to display customer underscore name, right? So customer underscore name, and then let's first write the table name. That's how I am wired to write the queries. You might have your own technique, but here let's say you want to just write a customer. I just like to write the table name first, so that if we are using more than one table, we are pretty much kind of, it is in my mind that I need to use 2 tables, right? So customer name, and then they want the count, right? So what they want, the count on the, so we can do a count star, right? Count on the customer name, right? And we can say as count, as occurrence, right? Okay, from customer. Now if you see count, so count is a kind of a a function. So you can't just write where, because you have to do a group by, because when you do a max or count, right, those kind of function, max, min, count, you have to do a group by, and I'll cover in different videos, right? I mean, what is the differences between where, group by, having, things like that, right? So group by customer name, right, because they want the customer name, they want the count, right? So count is a function, so that will not come in group by. Okay, and then you need to say having count of customer name greater than 1, because they want the appearances to for the more than 1, right? So let's just run this query. So if you see, Lindy and Beth both are appearing, right? So if you did not use the group by, right, what will happen is, if you just run this query, it's going to give you error. Customer underscore name must appear in group by clause or be used in an aggregate function. So these are all the aggregate function, count, max, things like that, right? So you can't just write like this, because when you're doing count, you need to group by certain things, right? So you need to group by customer name. So if they are asked you customer ID, then you need to group by customer ID, right? So and then group by, and then having. So you can't write where here. With group by, where will not go. Okay, where, okay, syntax error. Having, so having goes with group by. So this is one of the other interview question, that group by, can where go with group by, or how will you filter you using group by. So group by and having goes kind of together. So having is nothing but one kind of filter, but that clause goes always along with the group by. Okay, so this is our answer to the first question, right? The second query is, write a query to get the employees who are responsible for maximum number of customers, right? So this is a little tricky, right? I mean, this is little tricky. The reason is, they are saying that write a query to get the employees who are responsible for maximum number of customers. So when this question is given to you, right, you need to just read a sentence properly and see what tables needs to be used, right? So let's say they are talking about employees, they are talking about customers, right? So what is going to join customer and employees, right? So with that is something we need to think about. So if you see only customer table, there is a customer ID, but there is no employee ID, right? What we saw was, there was a customer territory table which has customer ID, and then employee territory table which has employee ID, right? But both of them have territory ID, right? So that gives you a click that both tables needs to be joined by territory ID, correct? So that is something you need to keep in mind. Just read the sentence, and from there you'll get a clue which table to use and which column to use, right? So write a query to get the employees who are responsible for maximum number of customers. So basically what they are saying is, give me the employees, right, employee ID, who are responsible for maximum number of customers, right? So this employee, if you see, can be responsible for, right? So if you see employee 1, employee 3, 4, 5, 2, 4, 5, 6, right? If you see here, each of them are belonging to different territory ID, correct? But if you see here, customer territory, what you will see, the Arizona has two customers, right? So moment you join the Arizona territory ID, Arizona, when it joins on Arizona, it will bring up two customers, right? And all other has single customer, right? So if you go to here, then you need to see where is Arizona, where is the Arizona listed here. So Arizona is employee one's territory, right? So the answer for this is, are responsible for maximum number of customers. So employee 1 will be responsible for maximum number of customers, right? So that's our answer. So let's get started. The thing is, so okay, so to get the maximum number of employees, what we need to do, we need to get a count, right? We need to get a count. We need to count a count of customer, and then we need to get the maximum of that, correct? Because if you just getting a count is not going to help here, right? They are saying maximum number, right? So first thing is get just write down the tables, right? So let's say from customer underscore territory C, let's just call this C, and then employee underscore map underscore employee underscore territory, right, where we need to join this, right, we need to join these two tables. So here, since employee name, correct, from the map underscore employee territory you have employee underscore id, correct, they want to get the employee, right, so this is our query, correct, just a simple query to make sure that, okay, so here saying we did not assign e to this, right, so let's just assign e to this. So if you see, we got the employees, right, employee numbers based on the territory, right, so if you see this based on the territory id, we got two employees, right, employee 1 two times, so that's the one that we need to get. Okay, now what we need to do is, so this is something that they are trying to test. Okay, they are trying to test our basically subquery knowledge, because here you have to write a subquery. Okay, so let's just write a subquery. So what do we need? Since we are going to select employee ID from here, so what we are doing is basically subquery is nothing but a query within query where we are kind of forming another table. Okay, underscore ID. Now remember what we wanted? We wanted a count, correct? And count of what? We want a count of customer ID, right? Right, we want a count of the customer ID, because otherwise how will we determine the maximum value, correct? So that's the thing, and then we need to rank them, correct, because so rank is a function here we need to use. We can use row num also, and I'll go through that, and I'll make a video where I'll cover different Windows function called rank, row number, dense rank, and things like that, and differences between them, right? Here we can use both row number and rank, and I'll tell you why. I'll just go through that, but let's just use rank. Rank, and rank always goes with the over partition by. Okay, so here we are not going to partition, because we are just going to simply partition by employee ID, right? So we don't need to write that. So order by, what we need to do, we need to order, right, we need to order by count of customer ID, right, and then we need a max, right, so we need a max, that's why what we are going to do is we are going to do descending, correct, because I just want to make sure we got the brackets right, because see, we want the maximum count, right, that's why we need to do descending. So what it will do is it will do 2 1, right, like that it will do. If you do ascending, it will give a minimum one, right, so which we don't want. In this case we want a maximum one, right, as rank number. Okay, and then let's just write row number also, because I just wanted to show you the results of that. Row underscore number, right, and then we can just copy this. So this Windows function will always go with the over clause. Okay, just keep that in mind. Okay, okay, so if you see that, right, and here we'll have to write a group by, because when we are writing count function, again count we used here, that has to go with the group by clause. Okay, and let's just name this table as X, right? So if you run this query, right, internal query, what you get is, see, you get employee 1, 2 customers like we saw, right? The other employees have 1 customers, right? So that's correct. Rank number, if you see, right, rank, so that's why I mentioned that in this case you will get rank number and row number, you can use either of that. The reason for that is because there is only one to count, right? So that's why what rank does is rank gives the highest number to the highest count, right, and it will do 1, and then it will basically, if you see, it is assigning the same count, same basically number to all three, because all three are matching, right, 1 1 1. So it's assigning the rank 2. Row number, what it does is just doesn't care about the rank, it will just give the number 1 2 3 4, right? So in this case you can use one of them. Okay, so here you can say where rank x dot rank underscore number is equals to 1, right? Select E employee ID. Okay, we need to use X here, right, because we are taking it from this table. Okay, so that's your answer, employee 1. Okay, so now here if we use row number, what is going to be the answer? Answer is going to remain the same. Okay, employee 1. Okay, so if we don't do that, so here see what happens. Here you get rank 1 to 2, right? Now if you see this, if you remove this descending, right, let's say we wanted minimum, then let's see what happens. So if you see, row number is employee 1, employee 2, 3, 4, it's assigning the row number. Okay, and rank, see what is happening, it's assigning the rank number 1. Okay, and then since all three rows are same thing, it is giving the rank 4 here, right? So that's the difference. Okay, so here also I need to remove it actually, right? We were not comparing like to like. So if you see here, now this is the correct one. So if you see here, when we did ascending, we basically it gave a count of customer, it gave rank 1, and then it skipped 2 ranks because all three are 1 row 1, right? So it will skip. But row number 1 2 3 4, so in this case if you do row number is equal to 1, you will get this. But if you do rank number, right, then you get all three, because rank is what is going to give. So I would use basically, rank always. The reason for that is count of customer ID DSC. Okay, okay, so the reason for that is because if you see this data, right, imagine employee 5 also had 2 customers, then what would have happened? You can't use a row number, right? Because if employee 5 also had 2, right, count of 2, they said maximum number of customers. So maximum number, they did not say only one, give me one, right? They said maximum number. So if they had 2, this would have, it would have assigned rank 1 1 to both of them, right? It would have assigned rank 1 1 to both of them, and then it would have skipped and said rank 3 3. Okay, row number would have remained the same, 1 2 3 4. So in that case, if you see 1, the second employee 5 would have missed out, right? So I think rank is the better option, right, when it's compared. So it will basically take care of the data, right? I mean, it will basically, if you have the multiple counts using the same having the same customer, right, multiple employees, then it will list all those employees, and that's the correct answer, right? So that's why I go with the rank in this case. Okay, now let's, so this here, what did it cover? It covered the subquery phenomena, right? Subquery, it covered the rank phenomena, right? It covered the rank function, which is a window function. It covered the count, which is aggregate function. It covered the group by, right? So, and then it covered the where. So remember, see the difference. Group by, I used it within this subquery, but I consider this as a table, right? I consider this as a table. I assign the table name x to this whole table, and on this table, since I am selecting only x dot employee id, I can use the where, which is a filter, right? So a lot of concepts covered here, right? I mean, that's what they'll test you. Like if you are writing a query, right? I mean, that's what they would like to test you, that whether you know all the concepts of SQL or not, right? So, and then finally other concept that was covered was inner join, right? Because you join two tables, and I'll cover the joins also in the in some other videos, right? But here we use the inner join. Okay, now there is a query, write a query to get, query number 3, write a query to get those employees having no customers, right? So if you go and look at this table, right? I mean, we need to use both these tables, the map employee territory and customer territory, right? Obviously we need to, since they're asking for both customer and employee, again we need to join through these tables. So if you see map underscore employee territory, right? So if you see here, there are around 6 different states, right? So if you see, there are 6 employees, and then you have 1 2 3 4 5 6 5 different states, right? California is common to employee 5 and employee 2. And if you see customer territory, you see around AZ, CA, Utah, Ohio, Arizona and Nevada, right? So if you see how many are common, I think Arizona was there, California was there, and Ohio was there, right? Arizona is there, California is there, Utah is there also, right? So New Mexico and MA are not there, right? So we need to, so our answer should be New Mexico and MA, right? Because those two are employees having no customers, right? So these two employees are having no customers, right? Employee 3 and employee 4, because it's not there in a customer table, right? So what we are going to write is select, and what are they asking for? Employees, right? So employee underscore id from map underscore employee underscore territory, right? That's the table that we are using, right? Where now they are saying those employees having no customers, right? Having no customers. So where, and what is the common basically column here? Territory ID, right? That's how we are going to get those data, right? So where territory ID not in, right? Not in, because we don't want those employees to, we only want those employees who are having no customers, right? So territory underscore id from, now we need to get the customer table, correct? Because we are looking for those employees where where territory id is not in there, right? In the customer table. So if you see, right, so where territory id is not in, select territory id from customer underscore territory. So if you run this subquery, you will get all the states, right, as we saw in customer table. And now what we are saying is find the employees whose territory id is not in this particular territory id, right? So as we saw, Arizona, Utah, Ohio and California were there. New Mexico was New Mexico and I think other state, right? Massachusetts state, I think MA was not there. Nevada is not there in both the things, so it doesn't matter, right? Nevada is not there in the other table also. So let's just run this query and see employee 3 and employee 4, right? That's what we wanted, correct? That's the result we wanted. So here, if you see the concepts that is again covered is the subquery concept, right? Because we had to write subquery for this. and then you are testing your knowledge whether you are able to find the data or not, right? So it's not a simple in, right? Usually it's exist or in. Here it is not in. You have to find something which is not there in the other table, right? So that's how this question 3 is there. Okay, so I think I covered 3 questions. I covered several concepts today. I request, my request to you guys is please subscribe to my channel and like my videos, right? I mean, this will help me kind of spend more time preparing this all these queries and preparing the questions, the concepts, right? And then these are the questions which are basically asked in Amazon Senior BIE or data engineer, senior data engineer, right? These concepts are definitely covered. The data obviously might not be exact, or tables will not be exact, but if you know this concept, it is fairly easy for you to pass that interview, right? And I can assure you that it will be one question will be there on the Windows function, right? I mean, or subqueries or joins, right? Because these are the very very powerful and very kind of code concepts of SQL, right? So it will be asked, right? So this will definitely help you progress in your interview and prepare better for your interview. So guys, that's it for today. I'll prepare another video. There is definitely part 3 coming up for sure for the another Amazon interview questions, SQL interview questions, right? Until then, thank you. Welcome to my channel. So today I will be going through the part 3 of the Amazon SQL interview questions. If you have seen my previous videos or you have subscribed to my channel, then you could see that I already made part 1 and part 2, and this is the part 3 of the series. Before I get started, right, I have a request to you guys that please subscribe to my channel as well as like my videos. That really helps me promote more and more content and make more and more content, gives me a lot of encouragement, right? I mean, I just wanted to bring up the things that some of my friends, right, are not even able to clear the first round of technical interview when they apply in Amazon BIE roles or data engineer roles. And this videos, right, and the concepts that we cover here will definitely help you clear the first round. So that's why I have a request that please subscribe to my channel. Okay, let's get started. So here in today's video there are 2 questions. The first question is about, like, they are asking, write a query to list the product names that did not have any sales. So for that, the 2 tables that are used, right? So the product table, product table has the data for all the products, right? So all the product like t-shirt, jeans, and then the product brand Nike, Levi, and then the market, right, region for those products. And the customer sales fact is basically it will store the data of which customers bought those products on which date and what is the value of those products, right? So this is typical data warehousing concept, right, where customer sales fact is a fact table and product is a dimension table. I am planning to create videos on star schema, snowflake schema, right, difference between both of them. So watch out for that video in future. So that will kind of cover those concepts. For today, let's just write a query, right? So if you see this data, right, so what they want is they want to list the products which did not have any sales, right? So either the order value should not be there, right? I mean, but the fact table typically will not keep a order, right, until there is a sale, right? So it will not appear. And as well as if you see this table, these products had a sales. But if you were to go and see the product table, right, there are 2 or 3 more products which are not there in the fact table. So if you see, all these products have a sales, but jewelry and apparel does not have. So what they are asking for is list the jewelry and apparel because it did not have any sales, right? So in this case, what we need to do is we need to do a left join. And this is the join concept they are trying to cover, right? They want to know whether you know the concepts of the joining between the 2 tables. So left join, what it will do is, left outer join means whatever table is there on the left of this join, right, which is a product table, it will bring those data even if that data does not exist in the table, sales table, right? That's what we want. If we do a inner join, the data will not come up because in that case jewelry and apparel is not there in the fact table, so it will not come up, and we'll try that. So in that case, and then you have to put a condition store order value is null, because they are trying to say, right, that did not have any sales, right? So that's why you need to put this condition as well. So let's just run this query. If you see, diamond and rings are coming up, right, because there did not have any sales. Now let's say if you do this inner join, right, instead of that you just do inner join, what you will get, you should not get anything, because though if you, when you are doing inner join, what's happening is it is just comparing the data between two tables. It is joining in, with, it's not going to bring those data which does not have a sales, right? So that's why you need to use left outer join, and that will probably be a right answer. Okay, so let's move on to the next query, which is a query number 2, and this is little tricky one, right? I mean, this is very tricky query actually. So write a query to list the managers whose salary is less than twice the average of the salary of the employees reporting to them, right? So for this, let's just look at two tables. So one is the employee table, typical employee table, right? Employee ID, employee name, employee city, employee date of birth, their pin code, and the salary, right? So if you see this, right, then and some of these are managers, right? So if you see the manager map employee hierarchy, here you have 6 employees. Map employee hierarchy, what you have over there is 4 employees only. Why? Because the other 2 employees that are there in employee is a manager, are the managers for those employees, right? So but employee table will have it, right, because even manager is an employee of the organization, right? So that data is there, right? So what they are saying is list those managers. So out of 4 and 5, which are the managers, correct? These are employees, they are not managers, these are the employees, but they are the managers. So show me if employee 4 or 5, if their salary, right, if their salary is less than twice the average of the employees reporting to them, right? So let's just see where the 4 and 5 are reporting, right? So if you see 4, 1 and 6 is reporting, 5 is 2 and 3 is reporting, correct? So if you see 4, 1 and 6, right? So 4 is 340,000, right, and 1 and 6 is 150 and 110. So what is the average of 150 and 110? 260, correct? 260,000, right? So no, sorry, that's the summation of those two employees. So that is 260, and average is 260 by 2, because 2 employees are reporting, right? So the average salary is 130,000, correct? 130,000. So what is the multiplication of 130 into 2? 130 into 2, because twice, remember they are saying twice the average salary. So 130 into 2 is 260,000. 260,000, okay, they are saying salary is less than average. So in this case 340, so it is more than average, correct? It is more than average. So 340 is greater than 260, right? So employee 4 should not be listed. Now let's say employee 5. So 2 and 3. So if you see 2 and 3, 200,000 plus 180,000 is 380,000. So 380,000, the average again is divided by 2 is 190,000, correct? 190,000. Now if you see the salary of now 190,000, okay, 190,000 into 2, right, because you have to do twice the average salary. So that is 380,000. So 380,000, and employee 5 salary is what? 300,000, right? So it is less, right? 300,000 is less than 380,000, correct? So employee 5 should come up, because employee 5's Tony's salary is less than 2 into average of Melissa and John's salary, correct? So our answer should be employee 5, right? So how to get it? So here we will use the concept of common table expression, right? So with CTE. So if you have worked in SQL and if you build complex SQL, you know that with CTE clause. So common table expression is nothing but you are creating a temporary table with a with clause. So if you see this, right, what I did is I created two different table, one as a manager salary table and one as a one is a employee average salary, right, table, because we need both, right? We need manager salary and we need the average salary of employees reporting to them, right? So that's why we created a two tables. It's kind of a temporary table that gets created, right? So we are basically, what we are doing is we are creating this table on the fly, right? So one is what, one we need manager salary, correct? So let's say, so how do you get manager salary? You get the manager employee ID from the employee hierarchy table, right? And then you get the salary of the manager, right? Or salary of the manager, right? If that manager, because we want to compare the manager salary, correct? So when you do that, what happens is employee 5 salary is 300,000, employee 4 salary is 340,000, correct? That's what you will get from here also. That's a manager salary, correct? 4 is 340, 5 is 300,000, correct? That's what we want. So, and then what we want is twice the average of salary, right? So twice the average of salary we want to take, right? Because what we'll do is we'll compare both of them in the final query, correct? So what happens is you have to do comma and then you need to write another table, average employee average salary is manager employee ID, right? And then you need to do employee salary, average employee salary, correct? And then you need to join both these tables, because that's how joining these two tables is how you will get the salary, right? Because the manager is what you will get from the employee hierarchy table, and then the salary is stored in the employee table, right? So you need to join employee and manager employee hierarchy table. Okay, so when you do this, what you get is employee 4 and 5 you get, and then so group by, right? The group by I covered in the previous video as well. So average is basically aggregate function, right? So when you do an average, you have to use a group by clause. Okay, so when you group by, we want to group by manager, right? Because finally we want to compare the salary, but we are taking, remember, we are taking average of the employee salary. Okay, we are taking average of the employee salary, because here what we are doing is we are joining on the employee ID. Okay, just remember that. Here what we are doing in the first one, we are joining on the manager employee ID, correct? Because we want manager salary. But in this one we want employee salary, right? We want employee salary. We are printing manager name, but we want employee salary, right? Employee reporting to them, correct? So that's why I said little tricky, right? I mean, it's going to confuse you. You need to make sure that you are reading the question properly and then writing the query, right? So first we will give you manager salary, so that's why you need to join on the manager employee ID and employee table, right? So that way you will get manager salary. Here you need to join by employee ID in the both tables, but you need to group by manager, because two people are reporting to each manager, right? You can have 5 people also reporting. So even if 5 people, 10 people are reporting, it will do an average of the people reporting to that manager, and then it will do 2 into that. So if you do that, then you get 2 into average salary, correct? So if you were to run these two tables, I think you can't do that. You need to write a select query. Okay, so basically what we are doing is we are storing the manager salary in this first table, and we are storing the 2 into average of employee salary reporting to that manager in this second table, right? So now what we'll do is we want to get the manager name, right? So we will join manager table and we'll join employee table on the manager employee ID, right? Because both of them are containing manager employee ID, where manager salary, right, manager salary is less than the 2 into employee salary. So we are not doing 2 into here because we already did it here, right? We already did it here. That's the power of creating the common table expression, right? We are creating a table with the requirement what we have, and we don't need to do that all these things in the filter condition. We just need to do it here. So we are getting 2 into average of the employee salary. So simple statement, right? Then less than manager salary is less than the 2 into employee average salary. So when you run this query, right, one thing you need to remember is you need to run this query together. Okay, otherwise it will not recognize it, because if you just run this query, it has to recognize, right, where the table is created, and that table just gets created during that runtime, right? So that's why you need to just make sure with this one the entire query is run together. Okay, so that is your answer, employee 5, right? Now let's try greater than. Do greater than 4 will come, right? Because 4's salary is greater than the average salary, correct? That's why only 4 came, but the requirement is 2 less. Manager salary is less than twice the average of employee salaries salaries of the employees reporting to that person, right? So manager is less than twice the average salary of employee. So we got the result that we are looking for. Okay. All right, so this is the tricky question. So let's go through, right, what concepts are covered in today's video. So first concept that is covered is join conditions, right, left outer join, and the filter condition also, right, where order value is null, right. The second query is little advanced concept they will try and cover, and this can come up in the first round of technical interview, or it could come up during the loop also. So Amazon does the loop, right? I mean, if you clear the first round of interview, you go with 4 or 5 people on one day, and then you do a loop. So several people will ask the question on the leadership principle, and there will be questions, technical questions also. So in that kind of loop interviews, the technical interview, this kind of advanced question can come up, right? Because this is basically with clause with common table expression. This is called common table expression. So with table you create, and then you create another table, and then you finally join those tables to achieve the complex requirement. So common table expression CT is covered in this. Then group by is covered in this, right? We are doing group by. The average function is covered in this, right, twice into average function, and then finally comparing the data in the final query, right, that is covered in this. So that's it for today. I hope you liked the video. As I mentioned before, please subscribe to my channel and like my videos if you enjoy my videos, and if you feel like it is helping you with preparing for the interview or in your day-to-day job functions also. If it is helping you, I really appreciate if you could subscribe to my channel and like my videos. Thanks guys. Everyone, welcome to my channel. So today I will be continuing with the series of the Amazon SQL interview questions, right, for senior BIE, BIEs, data engineers, senior data engineers, data scientist. So if you have seen my other videos, I have already covered 3 parts of it, and today is going to be part 4. And then one request I have is, so I'm going to link a playlist link, right, of this series, so that if you want to see all the videos, right, you can just save that playlist in your YouTube, and that way, it will be easy for you to follow along a different part. So I put a link on the playlist in the comment section. Also, before I start, I request all of you to please like my channel, like my videos, and subscribe to my channel, so that gives me a lot of encouragement to make this kind of videos. As well as if you want me to cover certain topics related to SQL or data warehouse or reporting, then please put it in the comments section, and then definitely I'll be more than happy to make videos on that. So let's get started with today's questions. Today's questions, if you see, right, it's more of a percentage based, like growth. We have a couple of questions where they want to see the sales growth from last year to this year, and then the percentage market share. So let's get started. So the first question is, so there are three tables: customer sales fact, which as the name says, it stores the customer ID, the product ID, right, and then the order date on which the customer ordered the item. So for example, t-shirt was ordered by customer 1 on 24th November 2021. That value of the t-shirt order was $54. The order ID is order 1, and then order month was November month. So customer sales fact is keeping this data for each product and what is the value of that product, right. And then customer territory is basically the customer's territory, and then customer city. I don't think so we'll need this column today, we'll need this table today. I think we are just using product and customer sales fact. So product table, if you see, customer is keeping the name of the product, right, product SKU ID, product SKU name, and then product brand and market name, right, which market it is belonging to. So it's a simple join, right? So if you see customer sales fact, you have product SKU ID stored here, so the join will happen between these two tables, right? So now let's get to the first question. So the question one says return Arizona territories sales growth from 21 to 22, compare the growth between year 2021 and 2022. So what it is saying is oh no, we are going to use, I think, customer territory table. Yeah, we are going to use customer territory table. So what they are saying is, if you see the territory, that's AZ, right, AZ is Arizona, right? So it's saying that for this territory we want to know the sales growth from 2021 to 2022, right? So if you see the customer ID is here and customer ID is in sales fact as well, right? So we'll have to join these two tables using customer ID, and then we need to put a filter on Arizona, and then we need to, based on the order date, right? So what are the products which are ordered in Arizona territory, right, where customer belongs to Arizona territory, and then what is the growth. So if you see here, there are two dates, if you see 2 years, one is 2021 and one is 2022. So for Arizona, what is the growth, right? I mean, so for example, in if you had let's say $100 worth of stuff ordered in 2021, in 2022 if you are ordering $140, then it's 40% growth, right? So for that, what we need to do is, since they asked 2021 and 2022, let's create the sales, let's get to the sales, right, first for both these years, and for that we'll use with clause, so with common table expression. And this is very important, right? I mean, if you see, if you have to write big queries, right, then definitely the common table expression is must. So if you have seen my part 3 video, I have explained about the common table expression, right? I have used their common table expression over there, and I'll make some other videos on what is exactly the common table expression, like we'll go detail into that for now. So when you use with and table name, you are basically creating kind of a temporary table within that query, right? I mean, so it's going to store this data of this query into this table, and we can reuse this table in the later on as you see in the later on queries, right? So if you see, let's start with the sales under 2021. So what we'll do is we'll get the year, right? So one other thing that is covered here is they are saying year, right? So if you see this order date, it's full date, correct? So how do you just extract year, right? So there is a command here. So if you see, there is a command called extract year in Postgres. So if you see extract, I think in SQL Server it's pretty straightforward. When you say year of order date, it will just get you a year, but here it's like extract year from order date from this table. So if you see, there are 2 years that is coming up. So year of order date and then territory ID, right, because we want territory as Arizona, right? So we need to put a territory also, and sum of order value. So sum of order value, right, sum is basically a kind of a aggregate function. So what it will do is, if you have multiple records, right, then it will basically sum up all those records, and then we need to join these two tables using customer ID like we saw. Since it is 2021 year, we need to put a filter on 2021, and then territory ID they said only for Arizona, right? And then since you use sum, which is a Windows aggregate function, you need to use group by, right? Whatever columns you are using here, so which is year of order date and territory ID, you have to group by. If you don't group by, it's going to give you the error. So if you see here, right, it's select distinct extract, order date must appear in the group by clause, right? So whatever you are here, you have to group by. So if you run this query, what it is telling you is 2021 year we selected Arizona as a territory, and the sales for the 2021 was $140, right? Similarly, we can create a same table. So basically, if you have seen, I have just copied the query, and then I just put here as a 2022, because everything else remains same, right? We just want a sales for 2022 for Arizona. So if you see here, it's 168, right? So what is the how much did it increase? 140, and then in 2021 168 in 2022. So if you see in a percentage terms, the sales increased by 28%, $28, which is basically, if you see, $28 is nothing but 20% of the $140, right? So if you take 20% of 140, that's 28. So if you add that to 140, that becomes 168. So basically the growth was 20%, and that is what the answer they are looking for, right? So once you have one, so what we had is, we had two tables. Just to recap, one table is keeping the value of 2021 sales for Arizona, second is keeping the value of 2022 for Arizona, right? So and then we have to just take a difference. So then we can write a query where sales territory ID, so territory ID is same in both, so it doesn't matter which table you take, but I just took it from 2022 table, right? So what we need to do now is, we need to take the columns from this table that we created and this table that we created, and then use a join here. Okay, so here if you see, its total sales 2022, which is 168, minus total sales 2021, which is 140, right? So basically it's 28 divided by total sales, that is 2021 is basically 140. So if you do this calculation, right, then you will arrive at a 20%, right? That's a percentage growth. That is what they are looking for, right? So if you see, from sales, both the tables, join it based on the territory ID, right? So when we run this query, we can't run this query standalone because it is using these two tables, right? So we need to run the entire query for the common table expression. Okay, so what you got is, sales growth is 20%. Okay, so that's your answer. Okay, so what we used here, we used with common table expression with clause, right, with city, and then we used year, we extracted year. If they said month, we could have extracted month, and then we looked at, since we want to see the growth, we looked at 2021 sales, we looked at 2022 sales, and then finally we compared the used this formula to come at the percentage growth, right? Okay, so let's move on to the next question. And again, before I move on to the next question, I'm going to create a playlist for all the Amazon SQL related questions, and so just you can save the playlist in your YouTube. That way, you can just look at each and every like video, one after the other, and then also please subscribe to my channel and please like my video, right? So let's move on to the second question. So in the second question, what it is telling, fetch the percentage share of each product name compared to its total market. Okay, so what it is telling you is, fetch the percentage share of each product compared to its total market. So let's look at the product table, right? So if you see each of the product, there is a name, white shirts, blue jeans, right? And then it has a market, right? So US West. So if you see this, like we saw, it's t-shirt, you can join with SKU ID, join with the fact table, right? And then you will get a sales for each of the product SKU ID, right? And it has the value. Okay, so what it is telling basically is, if you see the markets, right, you have US West market, and you have two products here, right? So t-shirt and jeans, correct? Or white shirts and blue jeans, correct? And then you have US Midwest, you have brown belts and diamond, you have US East dress rings, and you have US as bath towels, correct? So what it is telling is, if there is a sales of white shirts, right, which is $100, and let's say blue jeans is $40, then what is the market share of white shirts is basically, for the simple example, let's say total sales of the US West market is $100, for example, right? Just to explain you. Okay, we'll look at the data and then we can come at the query. So out of that, let's say white shirts has $60 of value, blue jeans has $40 of value. So what does that mean? That means is white shirts has 60% market share within the US West market, correct? So they are saying, so if you read the question, it is saying, fetch the percentage share of each product name, right, compared to its total market, right? So what is the market share of this? 60%. What is the market share of this? Blue jeans is 40%, correct? So what we need to do is we need to first get the sales. So we need to compare the sales of product and we need to compare the sales of market, correct? So similar to the year query that we had a growth of 2021 and 2022 growth, here we need to extract the sales value for the product name and extract the sales value for the overall market name, correct? Overall market. So if you see the product total sales, if you see product SKU name, product market name, right, we have to pull market also, right, because we will need this market name. Here if you see we are just taking product sales, but we are putting market name because we have to group by market, right, because each market, because market name, why we are taking, because here we have to join with the market name, right? When we do a final query of between two tables, we need a join, we need basically a joining a column, right? So that's why we have to pull market name here. That's not going to impact product's name because we are going to group by product name and market name, right? So lower level is product name, so it will group by product name, correct? So and here round sum of order value to. So here what I am doing is basically, this is another good example, good learning, that if you see the data of this order table, right, if you see the data of the customer sales fact, the data is stored as like without decimal point, right, 54, 100, 150. Here what I am doing is I am getting it in a 2 decimal point, okay. The reason for that is because if you have the uneven percentage, right, then you need a 2 decimal points. So here what I am saying is round it up to the 2 decimal points, okay. So I am going to do dot into 2 decimal points. So the thing is, it will just round it. Round is a function which will round it to the normal rounding, right, and then 2 decimal points as product sales, and then we join this two table based on product SKU ID and then group by. So if you see the data of this, right, so what happens is it is telling you the products sales. So Bart Towels has $168, Blue Jeans has $100, right, and if you see, if you observe, I got the 2 decimal points. So if the value was 168.67 or 78, right, it would have come like that. So that's I put it as a round 2, okay. The next one is we need to get the total sales of the market, right. So if you see here, it's a group by market because we have to get the sales at the market level only. If you put product here, it's going to, the query is going to remain same, right, which we don't want. We want the sales of a market level, so only put market and then group by market, correct. So if you see here, US overall market is 168, US West is 194, US Midwest is 20 and US East is 150, right. So now what we want is the market share, right. So what we want is product sales divided by market sales, right. So product sales is here, right. So individual product sales and then compare it to the market sales, right, and then basically you have to take a percentage. So in order to take a percentage, we have to multiply by 100, right. Here also we have done the same thing in the first query. If you see, right, we have multiply by 100, so we get a percentage, right. So if you run this query, so what you get, if you see, for US Midwest and US East, there is only one row. So if there is one row, there is only one product in the entire market, then obviously the percentage is 100%, right, because there is only one product, there is nothing to compare, right. But if you look at the data and you look at US West region, you had blue jeans and you had white t-shirts, correct. So blue jeans is 51.55 percentage. That's why we took a round 2, right. Here also we did round and decimal 2. If I just did if I did not do round, what it will do is it will just give me 51 and 48. So then it's not correct, right, because 51 plus 48 is basically 99, correct. So it will not give a complete 100%. That's why I did a decimal point. So what we can say is blue jeans has a 51.55% market share in the US West market and white t-shirts has a 48.45. So we can just compare this, right. So blue jeans sales we can compare. So if you see, if you run this query, right, so blue jeans is basically, so blue jeans is US West market, right, so 100, right. So if you see US West market here, US West market total sales is 194, that was coming up, right. So blue jeans is 100, So if you divide 100 by 194, that is around 51%, and if you divide 94 by 194, right, then it is around 48.55%, and 51.55 is for blue jeans, right. Uh, so basically, and this three markets has only one product, right. If you see, there is only one row. If US West also had, if US East also had another row, then then you will also see, you will not see 100%, you will also see the percentage division like you are seeing for the US West, right. So let me run this query again. So if you see the other three, since I had only one row, 100%, and US blue jeans is 51.55 and white t-shirt is 48.45, right. Uh, so that is it for today. I hope you learnt something from this video, right. I mean, obviously it is little complex, right. I mean, last video we used common table expression. Here we used it like in both the queries, right, because the query is little complex. It's asking you to compare the values of two different years, a market share of a particular product. So you need to get a summation, right, because it's just not one row we are comparing. We have to first get a summation, right, because there can be multiple rows, right, and we need to sum up the entire value, right, at a market level or at a product level, right. So that's why we need to write two different queries stored in the temporary tables, like with common table expression, right, and then finally write a query to join both these two tables and then get to the final question, final answer of the question, right, they're asking. So I hope this is helping you guys a lot, and if that's the case, please subscribe to my channel, and please like my video. I'll make another video, right, I mean, on Amazon SQL questions, or and I'll make more videos also on the data warehousing concept. I see that there is kind of a more demand for the data warehousing concepts like star schema, snowflake schema, right. So I'll try and make the make few videos on the concepts of those. For now, thank you all. Welcome to my channel Data BI SQL. In today's video, I'll continue with the series of Amazon interview questions, and I'll just go over a couple of questions, and in the second question, right, I'll also show a different method, right. Like there are different methods you can solve the queries, right, in SQL. So I'll show the couple of methods also today. But before I start, right, I request you all guys to please subscribe to my channel and like my videos. I have been getting some very good feedback from some of you that my interviews, my videos are helping you guys in your interviews. So if this channel is helping you, right, then please subscribe and like my videos. And I definitely want to hear your feedback as well. So one of the viewers also commented that please post the scripts, right. So of the DDL script, like create table, insert table, right, insert into table like data. So I'm going to post this scripts that I'm showing, that I created the tables and I inserted the data in the description of the video. So that way you can just copy paste this the scripts and then run it on your Postgres pgadmin tool, and then you will have the same data as I'm going to show you and the same table. So let's get started. So there are basically three tables, if you see, that are used here. So the first table here, the relationship is a little tricky. So if you see here, there is a product, there is a donations table. So the donation is so it's capturing donation ID, then donor ID, who is the donor, right, and donation date, the donation type, whether it's credit card, cash, debit, and the donation amount, how much amount was donated, right. The second table is the donation underscore products. So for each donation ID, right? So the donation ID is connected to this one. The donation ID, donations table had a donation ID. So here there is a donation ID, and for each donation ID, right, what was the product that was associated to that, the description, right, of the product, and then the product date, right, the product date, and then product price, price per product, right? So for toys the price is $100 and things like that. And then sales product, so the sales product will contain the sale ID for each of those products, not each of the product, not necessarily, like like you see here in one sale you can have two products, right? Very much like a real life scenario, right? In one sale you can buy multiple products, and what is the sales date, right? And then sales amount for each of the product. Okay, so those are the three tables that we need to work with. So the first query is give a monthly report of sales figures for each product for year 2021, right? So then when they say product for year 2021, for year 2021 they specifically mention, it's actually 2021, they specifically mention for a year. That means you need to just look at the data and then see whether you have multiple years in the table, right? So if you see that there is a multiple year, yeah, it is, right, 2020 is also there, so that means you need to put a filter, right? So just keep that in mind. When they ask for a specific year, just make sure to put a filter. So over here they are saying, they give the monthly report of sales figures for each product, right? So if you see this table, you have a date, you don't have a month here, so we'll have to do a month, we'll have to extract month out of this. And then we have product ID, right? Say for each product, they are saying for each product. So for each product, when they say, you need to look at the structure of the table. So you have so do you have product only in this table, or you have anything else? So you have sales also, right? So for each product, when they say, that means they are asking you to do group by, right? Because if you see here, there the product 6 is sold in two different sales, right? So if you just if you don't do a group by, then this row will appear separately, which you don't want, because they are saying that for each product you need to do it, correct? So that's why we need to do a product ID and then sales amount for each product, right? So first is extract month from sales date. So I if you see my part 4, I think part 4 or part 3, over there I have covered this. Over there it was year, here we have month and year. So since the sales date is just a date, there is no month, we need to extract month from that. So when you write this command in Postgres, extract month from sales underscore date, it will just extract the month. So it will just extract 11, 4, 5, things like that. And product ID, right, that's how they want for each product, right? And sum of sales, right? So you need to sum up the sales. So for P6 it should be 250 plus 30, 280, right? But here if you see, there is a trick, right? I mean, let's see what's the output. The output should be 250, because they are saying 2021 only, right? They are saying not 2020, so only 250 should come up. Okay, from sales product, where now you need to, again, like month, you need to extract year from this, right? So year from sales date is equal to 2021, group by, because you are grouping by month, right? They are saying monthly sales figure they want, and by for each product, right? So that's why we need to do group by and product both. Okay, and then I put order by product ID just for a good readability of the data, right? I mean, always you can put the order by if you want, even if it is not asked, because that's the way the data, the readability of the data is good, right? I mean, you can see in ascending order or descending order the product ID. So let's just run this query. So like you see, it's showing the sales month. So for sales month 11, there were two products sold, right? So there are two product. If they did not tell you product ID, then what will happen? If they say only show me the sales, then if you remove the product ID, then for month, sales month would have appeared only once, 11, and then the total would have been 300, correct? So just look at the question and determine the level at which they are asking the report, right? So just keep that in mind. Okay, so but here, since the product is there, so you have P1, P2, right, for month 4, P3, and then for P6, as you see, it's 250. It's not considering the other amount, because that was for 2020, correct? So let's say if like we mentioned, if they are saying that don't show it by product but show it by month, then what you will do is, basically you will just comment this out, right? and here I think the order by will also not make sense, right? Maybe order month will make sense. So like this. So as you see, it's just summing up on the month, and it sum up those minutes, right? Sum up those 11 for 11, combine both and show it. So the point being, if they said year, then you could have done by year, but they would have said, oh, 2020 2021, so yeah, show by year. Then you will say year, extract year, and there will be no filter, and then you will show the sales by year. So just look at the question and then try and determine the group by. Okay, so where whatever they say, by this much, by this particular attribute, right, or dimension, then just do a group by that dimension. Okay, so here since they ask monthly and each product, we just kept it like that. Okay, all right. Okay, now second question is, give list of all products donated but not sold. Okay, so just be careful about this. Okay, so give list of all products donated but not sold. Okay, list should include year of sales. Okay, no, I think it was not year of sales, it was just product ID. So I think I just yeah, it was not year of sales, because it was just product ID, because when I wrote the method that time, yeah, it's both product ID. So it was not here, it's by product ID. So list should include product ID, donation ID, description, date of donation, okay, and then sales amount of the product. Okay, so over here if you see, so give list of all products donated but not sold. Okay, donated but not sold. So you need to see donation of the product, right? That's where the donation donated. So for each of this product, donation ID D1, D3, D4, D5, D6, D7, right? So for one donation, obviously you can have multiple products, right? So the list of products which are donated. Okay, so these products which are donated, correct? Now they are saying that but not sold. So this product is donated but not sold. So how will you find out it's not sold or not? So sales is happening in which table? Sales data is in the sales product table, right? So if you see this P1, P2, P3, P4, P6, P1 to P6 is sold. Let's see donation products. So donation underscore products, you have P6, P7, P8 also, right? So P7, P8 is part of the donation product but not part of the sales product. So that means these two are donated but those are not sold, correct? So our answer is P7, D7, P8, D7, right? That's our answer. And the description also they are asking for. So tables and spoon also we need to show. Okay, so now I will show you the two approaches, right? There are two approaches to solve, and this method, right? I mean, it gets evolved, and everybody has their personal way of writing the query, right? I mean, everybody gets into some kind of a habit. I mean, some people like writing the queries using joins, and some people like writing using a subquery. And then if possible, the subquery should be avoided, because subquery can cause performance issues. In this case the data is very less, so you don't realize that. But if possible, try and not use subqueries. You can refer to my SQL performance video right on my channel, and there I have put the points which should be considered to improve the performance, right? So one of them is like, don't use subquery, use with CT, right? I mean with common table expression, and I have the video, I think part 2 of Amazon interview questions also on that. So just refer to those two videos. But anyhow, I want to show both the method, right? So that way, whichever method you like or you're comfortable with, you can use that. So the first method I'm using is the sales is a outer join, right? So right outer join, left outer join, and I prepared a join video as well that you can refer right on my channel. So right outer join, what we are doing is, when you say right outer join donation for, that means what it will do is, even it will bring all the data in donation products even though the data is not present in sales product, and that's what we want, right? That's what we want. There are
there are P7, P8 products which were donated but not sold. So that means we want everything that is there in this table, even if that is not available in this table, right? So that's why we wrote right outer join. Okay, and product ID is the common column between that, right? And there, here we are saying where sales amount is null or sales amount is 0, right? Because what happens is, if those products are not there in that in the sales table, it will bring the null value, right? And the second scenario that can happen is the sale the product can be sold, okay, but it has a sales amount as 0, okay, that is also possible, right? It's basically because, you know, I mean, ideally it should not be the case, you know, but they can trick you, right? They can give the data like that, so you need to be a little careful, right? I mean, not sold, that means, you know, basically 0 also, right? The amount is 0 also. So just for a careful purpose, I just wrote both, like or condition, where it's null or it's 0, okay. Group by product ID. If you see the table data and you don't see the 0 sales, then don't write this, okay, that's fine. In our case also it's not there, so it's okay if you don't write it, but if you see it, then just make sure to write it. I mean, just put or condition also, okay. So if you see this, right, and group by product ID, donation ID and description, right, so that's what they have requested. Excuse me. So if you see here, right, P7 and P8, that's what our answer, right? So if you see, the sales amount is coming as null, right, because those two are not available in that table, right, in the sales table. So here the concept what we covered is the outer join, right, outer join, right, and then where condition also, right, because that's basically there is no sales amount, right, there is no sales happened for those two products, even those products were donated, okay. Now the second method is to write a subquery, right? So if you see, the product ID, donation ID, description is all in one table, product donation products table, and then where we are saying is where product ID not in, right? Because these product IDs P7 and P8 are there in this table, but it is not, we want only those product IDs which is not available in the sales table, right? So you can say not in product ID from sales underscore products table, right? So this is basically you're writing a subquery, right? So here you're writing a subquery. So tables and spoons, again the same answer, right? I mean, if there are any other products which will come up which does not have a sales, it will automatically be picked by this query, right? And even this query will pick it up, okay. So there are two different ways. One is through the join you can write the query, and one is through the subquery you can write the query, whichever framework suits for you, okay. All right, okay. So that is it for today guys. I hope you are liking my videos and like my channel. You know, I hope I'm producing very useful content for you guys, and if that's the case, right, please subscribe to my channel and like my videos, and that's going to give me a lot of encouragement to create more and more videos. Thanks all. My channel, database SQL. So in today's video, right, I'm going to cover a little bit of complex question, right, in the series of Amazon SQL interview questions, and this is little bit of complex question which probably, you know, can come up in the second round of technical interview, right. I mean, Amazon usually has first round of interview, technical interview, and then when you go and interview with 4 or 5 interviewers, there also there is a technical round. There can be 1, there can be 2 also in that interviewers who can take your technical assessment of the technical skills. So this will probably, you know, it's a complex query, it's a subquery, so this will probably come up for senior roles like senior BIE, senior data engineer, or senior data scientist. It can come up in BIE roles as well, BIE, and probably in second round, you know, BIEs or data engineers. I think data engineers might have it because data engineers are more close to writing more and more SQL than the BIEs, right. I mean, data engineers day-to-day job is obviously to touch the SQL. So this knowledge could be tested, and one of these kind of complex questions will come up. And so this is so we are going to solve that using a subquery. You have to write a subquery for this, you know, there is no other option. by which you can solve this. So we'll just get right into this. Before I proceed with the video, right, I just had a request that please subscribe to my channel and like my videos, right. That gives me a lot of encouragement. So let's get to the question. So here we are dealing with two tables. One is customer, and if you have seen my previous Amazon SQL interview videos, then these two tables are very familiar to you. If not, then I would recommend that you go and check out my other videos. This is probably a part 6, right? I mean, I have made other 5 parts. I'm going to add all of them to the playlist. So just go and check out the other videos as well. So customer table, right? I mean, for those who are new and watching this video and have not watched other videos, the customer table is pretty straightforward. Customer 127, then customer name, customer city, customer date of birth and pin code, and then customer sales fact basically joins with customer through customer ID, and then stores the product level information, like each customer bought which product on what date and what was the order value for that particular order, right, for that particular product on that order date. Okay, so now the question is, find the customer with the highest salary, highest daily total order cost between 2019 to 2021. I think I have, it's 2021 actually. Actually it is between, the question was like between Q3 2021 and Q1 of 2022. Okay, so it's like that. So basically what it is telling, that during this period of Q3 2021 and Q1 2022, find the customer which did the highest daily order. Okay, so it's by day, just remember that it's by order date. For each date they want to know, so in this 2 quarters, for each order date, what was the highest, like who was the highest, who was the customer which ordered the highest order value during any of the days which falls between these 2 quarters, right? I mean, that, if that makes sense. So basically Q3 is what, Q3 2021, Q4, it's Q4, sorry, Q4 2021 is basically your October, right? I mean, October 1st to December 31st is your Q4, and then Q1 is January 1st till 31st January, 31st March is your Q1 of 2022, right? So it's basically the 90 days or so, right? I mean, more than 90 days, not 90 days, 90 plus 90, 180, more, around 180 days period of time, right? Between those dates, who was the customer which had the highest daily order value. Okay, and then second line, read the second line. If customer had more than one order on a certain day, sum the order cost on a daily basis. So if you see this, right, if you see the customer sales fact table, do you have one customer ordering? Yes, one customer is ordering 3 times. 2021 12/8, 2021 5/22. Since 5/22 will be out of picture, right, because it's 2021 May, which we are not considering, and then 2022 1/18. So customer 2 is 2 transactions, but then the dates are different, right? One is in 2021, one is 2022. So these transactions also need to be considered separately, right? So if you see this overall table, right, and this is less data, but if you have more data, then also this query should work, right? So if you see this, you have to ignore the June and what else, the May, these 2 records, because they are saying start from October, correct? So out of this 1, 2, 3 and 6 records, which is the highest value for the day? 168. So 168 is towel, right? And customer name, we'll see who is the customer name. Customer 2 is Madison, right? So Madison and 168 should be an answer, right? If you had, if we were to make it more complex, right, obviously we can add, I mean, it's obviously dummy data, so we can add another transaction for 118, right, for customer 2, and say like shoes, for example, and then let's say 100, right? So then it will make it 268. Okay, because you have to group by date. That's what they are telling you, right? They are telling that on a certain day, right, on a certain day, and total cost between customer with the highest daily order, right, daily total order. So that's why you have to group by order date. Output their first name, the order date, and the total cost for the order date. So again they are saying total cost for that order date, right? So if you had two transactions here, you would sum up both the transaction and it will be 268, okay, for Madison. That's how that's the output they want, right? So how do we write it, right? So what we need to do is first what they are saying, customer name, order date, and sum of order. So customer name, if you see, it's not there in the order date, is in the sales fact, and order value is also in the sales fact, but customer ID and customer name both are in the customer table, right? So you have to do a join, correct? So that's the first step, okay, do a join on customer ID, right? Then since they mentioned cost between, right, they're saying between, so that's why just put the dates, right, like we discussed, like I showed, it's quarter 1, October 1st, and then end is 31st March, right, between. So when you do between, again this is the between clause, I think we have not used in other videos. So between is between two dates, so it will take all the dates between those two dates, right? So so this clause is covered. Now let's say obviously they want customer name and order date, right? So that means you have to just put those two and then sum and the total cost, right? So total cost, so summation. So now obviously when you do summation, which is a Windows function, it will not allow you to do without group by, right? So group by, what you will do, customer name and order date, both you have to put. So let's just run this query, right? What happens? Okay, so you get 4 different values, right? You get Madison 2 times, because why you get Madison 2 times? Because we are putting order date also in group by, right? If you did ignore the order date, you could have got Madison 268, but that's not the case, right? Because you have to put order date. That's what they are saying, put the order date also. So in a group by, you have to do group by of customer and group by of order date both, okay? So now we got the data set, right? But is it solving the issue or the question we have? No, right? It is saying that find the customer with the highest daily order, okay? So here you have 4 customers, that's not what they want, right? So out of this 4, we need to determine which is the highest order. What is the highest order? 168, right, for 118 and Madison. This should be our answer, right? So now we need to, this is the first part where you got the summation, right, of the order value by date and by name. Now our second step is to find out the max of this, right? So now what you need to do is, with group by, the having goes, right? So having is basically a filter on the group data, right? What's the difference between where and group by, right? I'll cover I'm planning to make a video of differences between few things, right? So where and group by, then union and union all and things like that. But for now, so group by, where is just a simple filter on the row data, one row, okay? So raw data, right? I mean each row it will apply that filter when you say where. So like it did here, it is scanning through all the order dates and between it is doing between, okay? Group by is basically a filter on the summation data. So here what we did, we summed up the values, right, group by customer name and order date, and then we are applying filter on that. So for that, the having is the clause that goes by, right? So we are covering so many concepts here, right? Some is the Windows function, then we are covering between, we are covering group by and having, right? So this basically obviously, and then we are going to do subquery. So obviously it makes it very complex, and we are going to do max also, right? Because we need to find out max out of this, correct? So now what we need to do is having sum of order value. So what we are saying is, find the match of for this, right? So find the match where you get 168, right? So then you say select max of order value, right? We need to do max because we need to find the maximum of this, right? Max of order value from, and there is another subquery within the subquery. See, that is where it makes so complex. This is already a subquery, and within that you have a subquery. That select sum of order value, right? Again, sum of order value as order value from customer sales fact, where order date between, again we are applying this filter, and group by customer ID and order date, because that's what they are looking for, right? So what will happen is, it is again creating this data set, okay, just summing it up by order value, okay? It's not, if you see, it's not putting customer name and order date here, and we'll see why it is not, it will not work, right? I mean, you could have said oh, just take this query and do it, right? why would you want to write this whole subquery? No, but it will not work. I'll show you. You have to do it like this, because within the subquery, if you see the difference here. Here we are printing what they are asking for, but in this subquery we are not grouping by customer name and order date, because if we do that, again it will give this output only, right? So we don't want that. So that's why you are saying we are purely concentrating on the order value, correct? So if you see this, if you run this query, it is giving just order value, right? It's just giving order value because we are looking for the highest order value. The other data we already got it here, right? So that's why we just have to get this value, and out of this you are taking a max, correct? So you will get 168, and then what it will do is it will match 168 and then it will get the data. Okay, that's how it is. So if you run the whole query, it should give you the answer that we are looking for. Okay, Madison, first name, the order date, and then total cost of order value, which is 168, right? So that kind of, this query kind of makes it very complex to write. Now let's get to the issue we had, right? Like the one that we are talking about. So let's say we are saying like this. Okay, so here if you are going to put customer ID, okay, and order underscore date, okay, you are already doing group by here, so you don't need that group by. Okay, what you get is again this four row of data, right? Now if you were to just write it using this query, they asked everything, right? They asked the data, right? Like customer ID also they want and order date also they want, correct? Let's do this. Will it work? It will not work, right? Because what it is saying must appear in a group by clause. If you see, this must appear in the group by clause, it is saying, right? Because it's you are using an aggregate function, you are using max, correct? So what you need to do is, again you need to write a group by, because see, just follow along, this is another subquery, correct? So consider this as a table. Okay, so now you need to write another group by customer ID and date. Okay, order date, correct? What is happening? It's printing the same output. Why it is doing that? Because it is grouping by customer ID and order date all the time, right? So if that happens, it will obviously print. So if you see customer ID and order date group by, obviously you have one row only, right? You will get that same row because there is only one order. Okay, if there were multiple order like we saw for medicine, right, customer to customer, if these two were on the same date, it will print 268 because it's on the same date. Okay, and it will sum up the value. But here it's not doing that, right? It's just basically what it is doing. So in this case it's just again grouping by customer ID, order date, and then doing a max. So obviously the value remains the same. That's why you can't do that. You can't do that. That's why you can't solve this without writing a subquery. So if you see the difference, what we did here is we got all this data here, and then we did max of order value, and then the subquery that we wrote, right, for the table, we did not put customer ID and customer name and order date. We just put out of these four values, right, what is the maximum needed, correct? What is the maximum out of this four? That's what you want, right? Because the customer name printing and order date we are doing it up, so we don't have to do it here. We just need to look at the overall order value and then do a max out of that, right? So it's pretty complex query, right? I mean, you just need to see, if you see in this question, it is actually straightforward actually, if you see, right? I mean, they have outlined also in 3 different lines. They are giving you step by step, right? I mean, they're giving clearly outlining it. It's just that you need to think about it, right? When they say cost between Q4 2021 and Q1 2022, you should not get confused. Oh, what is this? Where is the quarter? Okay, where is the quarter, right? I mean, you will search in this table and see, oh, where is the quarter, right? No, Q4 2021 means like October 1st to December, right? I mean, if you have a confusion about it, you can ask the interviewer, right? I mean, how do you define Q4? uh, do you define Q4 at October to December, or you define Q4 as January to March, right? Because if you see different countries like US, Q4 2021 is December quarter, but India Q4 2021 would be like something like January to March 2021 actually, because the financial year is different in India and in US, right? So you can ask the interviewer about that, what date you are when you say Q4, which month, right? Which months are part of that, right? So but here I have taken a US example, right, where it's October to December and then January to March. So then you know that start date of that quarter, right, and end date of the second quarter. So then just put it in between, just frame it in your mind, just try and frame this entire query, like, first try and see what will be the output, right? Just look at the table, see, it's not a complex data, right? Straightforward data. Out of this, if you see order date, when they say customer first name and the order date, just see customer ID and order date, right? And then see the maximum value, which is the maximum 168. Okay, so just try and frame it in your mind that this will be the output and I need to work towards achieving it, right? Then go step by step. So whatever they want, just put it first, right? And then put filter condition, everything, get the tables in order, and then go to the next step, right? I mean, you got the summation, you got all the values, now you need to find max out of that. How are you going to do it, right? So just try and structure the query step by step, and then you should be fine. Okay, so I hope this was very helpful, and it's a complex query, two subqueries we had to write to achieve achieve what we want. So I just hope that this was very useful to you guys, and then if that's the case, then I request you to please subscribe to my channel and like my videos. Thank you guys, bye.
Channel database SQL. In today's video, I will try and cover some of the questions related to employee salaries and employee manager relationship and things like that. So we'll cover different concepts here as well. So before I start, right, I just wanted to request you guys to please subscribe to my channel, like my videos. I have been putting a lot of effort to get this data, like data prepared, table prepared. So and I put a lot of effort in coming out with this query. So I just request you guys to please subscribe to my channel and like my videos. So let's get started. So today, two tables we are going to deal with today, right? So it's first is a employee table, typical employee table where employee ID is there, employee name is there, city is there, date of birth, pin code, and salary is there. The second table is what basically the shows the relationship between the employee and manager, right? For each of the employees, like who is the manager and things like that. So these are the main two tables we are working with. Both can be joined using the employee ID as a common key. So there are three questions we'll cover. The first question is display employee ID and employee names of for those employees who are also managers, right? So we just need to display those employees who are also managers. So for example, uh, if you see here, the who are the managers? Employee 4, 5, 7, 8, and 9 and 10, right? So if you see employee 1, 2, and 3 are basically 1, 2, 3, and 6 are not managers, right? So those should not come up. So that's what we need to write the SQL on. So what we'll do is probably we'll join both the tables, right? We need to get the employee name and employee ID, right? So we'll join both the two tables, and then we'll say where employee employee ID of the employee table is equals to manager ID, right? Because if you see this map hierarchy table, then we need to only bring those employees who are managers, right? So that's why we need to match the employee ID of the employee table with the manager ID, employee ID of this table, right? So that's how you will see. So what it will do a join of manager employee ID to the employee ID of the employee table, right? So that way you look at only managers. So let's run this SQL. So if we run this SQL, we'll get only those employees who are managers, right? So as you see, 1, 2, 3 has not come up here. 4, 5, even 6 is not there because the 6 employee 1, 2, and 6 are not managers, right? All other people are basically managers. Okay,
So that's the first question. Second question is show top three highest earning employees, right? So if you see, if you look at the employee table, you have the earnings, right? Salary. So top three highest earning employees is what they are looking for. So if you see 340,000 is the first one, right? Second salary is 300,000 and third salary is 280,000, right? So these three should come up. Now top three highest earning employees, right? So these are the employees we should show. So here let's just select employee ID, salary, and the rank, right? So rank cell is I'll get to that function. Here we'll have to use the dense rank function. So what we are doing is we are going to write another subquery, right? So because we need to come out with this rank function, correct? So what happens is when we do the employee ID, salary, and dense rank, so what we are trying to do is we are trying to in this query, what we're trying to do is we are trying to assign a rank to the highest salary, right? Highest salary employee. Okay, so if you see here, if you run this query here, see what happens is it is 300,000. Okay, 300,000. And why we are using dense rank, right? I mean, we'll just get to that because we have to use dense rank here. So if you see 340,000 and 300,000, there are two employees making that money, right? So that's why we have to use dense rank. And then third is 280,000. So our answer should be 4 to 10, correct? So let's just, when you run this query, it's showing this 4 employees, okay, which is correct answer. So now what we need to, why we need to use rank, because if you see, let's just concentrate on, this is the most important part of the query, okay? The other things are pretty simple pull, but this is the most important part of the query, okay? So that's why let's just concentrate on that. So if you see here, what we are doing is select employee ID, select salary, dense rank, and I'll get back to the two functions, right? Dense rank and rank, right? There's a difference between both of them, and we'll get back to that. So if you see dense rank, okay, and then over order by, over partition by, over order by. So just remember that we can do over partition by and we can skip the partition by also. So we need to skip the partition by here, because if you, what are you going to partition by, right? If you're partitioning by employee, then it will not work, right? I mean, because it will just partition by each of employee. Okay, so we need to over order by salary descending, right? So they are saying top three, right? So that since you are doing top three highest earning, we need to do salary descending, right? Because if we don't do descending, then what it will do is it will start ranking based on the 110, 150, like that, right? We want it from the top. That's why we are saying salary descending as rank cell, right? And then we are saying that just, and we are making this table as table B, and then what we are doing is where A is A employee ID is equal to B employee ID, and then rank 1 2 3. They said top 3, right? If they said top 4, we just need to do 4 here, okay, and then order by cell, right? So if you do this here, you will get top 4, okay, 1 2 3 4, right? So that's the answer. But I want to highlight here, let's just take this query, okay, and then let's just run a different what do you say, dense rank, okay? So let's say here we say dense rank, okay, then we will say, so what we want to do is basically we want to compare the dense rank, okay, and then row num also. So row num also is the is another function, okay, that can be used in so here you could have used row num also, either one of the three you have to use. But the reason why we need to use dense rank is, okay, okay, so let's do one thing, let's just run this query, okay. Okay, so if row num is pretty straightforward, okay, so what it is doing is based on the descending order of the salary, it's just assigning 1 2 3 4 5 6, okay. So here can you find top 3? So if you were to say top 3, you say 1 2 3. Is that the correct answer? No, because 300,000 two people are making, right? So you need to consider top 3, so you can't just say these are the top 3, right? Because the salary you have to see top 3 salaries, okay, not top 3 employees, top 3 salaries, 340, 300 and 280, right? All three should come. So that's why row num will not work. If they had distinct salaries, yeah, then row num will work, okay, but you don't know, right? I mean, the data can be stored. You I mean, it will be very common scenario, right, where two employees are making the same amount of money. It's very common. So that's why I'm just trying to show the difference, but here you can't use row num. Now look at the rank. Okay, there is a difference between rank and dense rank, and the reason why we use dense rank, right? If you see rank, what it does is it give the rank one. Next time when you have the same salary, it is giving to second rank to two. That is correct, okay. But then for next one, if you see, it is skipping the rank. It is skipping the rank, right? It is saying because you finding two rows of same number, so it is skipping the rank three. It is going four. So if you see 1 2 3 here, what will happen again? You will run into issue. You will not get the fourth guy. I mean, because two people are making the same money, right? So you will not be able to show. You will not be able to get this accurate answer. In dense rank, what happens is you have employee four, so one, and then you have second assigned, and then when it is going to next, it is not skipping the rank, even though you have two rows with the same salary, two rows matching. Next time it is going to give, not going to skip the rank. So that's what we want, right? We want top three highest right? I mean, top three highest making salary employees, right? So here there are two. That's why you see 1 2 3, you are basically getting a correct answer, right, when you're using a dense rank. When they said 4, you can just put 4 and this will take 4. So dense rank will be accurate in this case because it's not going to skip the rank, right? So that's the difference between the dense rank and the rank and the row num. Very important. This is basically they'll try and trick you with this, and it's good to have your concept very in your mind very well, that I need to use dense rank when I need to use dense rank, when I need to use rank, when I need to use the row num. Okay, in this kind of scenarios, right? Obviously, the safest option is dense rank. You should use the dense rank because it's not going to skip the rank, right? Versus rank where it is going to skip the rank. Okay, so just keep that in mind. Okay, so here we got the answer, right? So top three highest running is 4, 5, 8, and 10. Okay, all right, so that's the correct answer. So now the next question is display those employees who are reporting to same manager. Okay, so what does that mean? That means that you have to report those employees only who are reporting the same manager. Okay, excuse me. So here if you see, employee 1 is reporting to 4. Is anybody reporting to employee 4? Yeah, you have employee 6. Employee 2 is reporting to 5. 3 is also reporting to 5. So yeah, this is also a candidate for that. But 4 is reporting to 7, 5 is reporting to 8. So 7, 8, 9 and 10, okay, there are not more than one employee reporting to the same manager, right? There's only one employee, one manager. Okay, but here they are asking that display those employees who are reporting to the same manager. Okay, so our answer should be 4 4, right, and 5 5 should be the manager ID, right? So if we see this, so we need to just so in this case, right, you have the employee and you have manager in the same table stored, right? So in this case you'll have to use a self join. Okay, so if you're doing here, okay, what I'm saying is I just created a table alias. I created the first table and named it as employee. I took the same table and named it as manager, correct? So you just need to just do a self join. This is called self join. When you use the two table twice, you just call self join. But here if you see, what I am doing is employee dot manager employee id, right, is equal to manager dot manager employee id, right? We need to match the manager id of both, right? Then only you will get this combination. And employee id is not equal to manager dot employee id. Okay, so because the employee id should not match, right? Because if you remove this, so let's just run this query. So if you run this query, you are getting the answer, right? 1 6 both are reporting to 4, 2 3 reporting to 5. Now if you don't put this option, right, what it will do is it will bring all the rows, right? Because it's going to, okay, this it's not allowing because of end. So if you see this, it's bringing all the employees 7 8, right, 9 10. because here what is happening is you are saying that manager employee ID and manager employee ID just match, correct? That's what, that's what we are doing. So we are just matching those two IDs, and then manager dot manager, it's just going to match like to like and bring all the rows, correct? So that's not the correct answer, right? Because we need to also make sure that no two employees are right, then only you'll get two different employees, right? So no two employees, both employee ID are not matching, right? That's why you need to have this, condition where you will say and employee dot employee ID is not matching with the manager dot employee ID, right? So between two tables, when the employee ID is not matching, when both are distinct, then only display the rows. Okay, so if you are going to do that, then you will get the correct answer. Okay, so here the concept of self join is used, right? So whenever they are saying employees who are reporting to the same manager, and you see that in the same table, then just kind of should click in your uh, brain that it's basically going to be a self join, because both the columns are on the same column, and they are trying to get you the data which is coming from the same table, right? So for those employees who are reporting to the same managers, so that's why you need to just create table alias, create the table, user tables two times, and then just give a different name and do a self join based on the manager employee ID, and then just say that employee ideas are not matching, right? So because you need two distinct employees who are reporting to the same manager, that's why you need to use this condition. Okay, so this also is giving this query is giving the correct answer. Okay, overall, if you see, right, what we have covered is we have covered the basically this rank, dense rank, and row num function, right? I mean, difference between those. We use the dense rank to get to the correct data, right? And also we use the self join concept here, to get the data we want, right? So those are the two kind of main concepts covered in this particular video. So I request you guys to please subscribe to my channel and like my videos if you have been enjoying the videos I'm making. I have made a lot of the other videos as well. So this is the part 7 of the series of Amazon SQL interview questions, and I'm going to add that to the playlist as well of Amazon SQL interview questions. So just if you want to go through all the videos, then just go through play the playlist, and you will be able to see each and every video. Okay. So all right, then talk to you later in the next video. Thank you. Welcome back to my channel, Database SQL. So today we will go over some of the interview questions related to user table. So user table, right? It's very important to many companies, right? I mean, not only for Amazon, but any other retail company you take. Obviously, the user growth, the frequency of user, the active users is very important to retail industry as well as social media industry, because you want your users to be engaged, right? I mean, they will do a various count, like daily active users, they will say monthly active users, yearly active users. Obviously the companies would prefer that they have higher daily active users, but if not, at least higher monthly active users, and that growth should happen, right? I mean, because if the users are just coming for 1 month and not coming for every month, or just coming once or twice in a year, that's not a good sign. More users growth you have, more engagement you have, more your product sales or more your advertising can be on social media. So it's very important table. It is very common for these questions to come up. So we'll just go over some of the questions. But before that, right, I mean, please subscribe to my channel, I request you guys, and also like my videos. That gives me a lot of encouragement to make more and more of these kind of videos. Let's get through the tables, right? So if you see, and one other thing I wanted to mention is I'm putting all the scripts in the comment section of the video. So if you see the create table, insert table, right, data, and all the select scripts also I'll try and put. Sometimes there is a restriction of 5,000 characters in comments, so if I'm not able to paste all the rows, like there are 37 rows here, then I'll truncate some of the rows, like I'll remove some of the rows, and then
you can you can add it on your own, or you can just work with a data set like 20-25 rows, and that should also work fine. So all you need is just Postgres admin pgadmin, and then install it, and you will run the script, and you will be able to see exactly the same replica of the data on the tables that I am showing in the video. So let's get started. So here there is a user table, pretty simple, right? I mean, user transaction. So there is a user ID, there is a item which is purchased, there is purchase date, there is revenue. So if you run the table, I am just trying to order by user ID. So if you see pretty common, like user ID, and then there's item that is purchased by this user ID, then there's purchase date, and then there's revenue for each of the item. So the first question that is asked is find out the daily active users, display user ID and purchase date. Right. So what they are saying is give me the daily active users count. Right. So since they are asking by purchase date, what we'll do is purchase underscore date and then count of distinct user ID. Okay, this is very important. Okay, and do it on user ID, not on ID, because ID is common. ID is like a primary key. It's not defined as primary key, but it's like a, if you were to just sort by ID, then it will be like 37 rows. So you need to do it by user ID, and you need to do distinct. Because why? Because one user can come purchase two items on the same day, right? That's possible. So you don't have to double count that user because it's by user, right? It's not by how many times the purchase has been done, right? I mean, if they say give me the count of total purchases by that user, then that's a different thing. But here it's count of distinct count of users coming daily, right? So if one user come two times, you don't have to double count. That will bump up your user count. So just make sure that you put distinct. Okay, from transaction, right? And you have to use group by. Okay, because if you don't use group by, it's not going to work. See, the transaction must appear in group by because it's an aggregate function. So count is an aggregate function, right? So that's why we have to sum, count, all those are aggregate functions. So we have to group by, and they want to see it by group by purchase date, right? So group by purchase date. And then if you want to do order by, that's fine. It's not being asked, but let's just do order by. Okay. So if you run this query, I think I did not select the entire query. Right, so it is giving the user count. For 3, it is 1, 3, 4, it is 2, and 3, 18. If you see, there are 4 users that purchased the item, like there are 4 distinct users, so it is giving you the count by each day. Okay, 18 to 2022 is giving 3. Okay, so that's your daily active users. Okay, next is find out monthly active users, display user ID and month of purchase. Okay, so here what we need to do is, if you have looked at my other videos, I think in part 4 I covered this. You can extract month and year from the date, right? So here if you put extract month from purchase underscore date, okay, as month. Okay, display user ID, year and month of purchase, right? So you need to put year also. Okay, so you need to have year also. Okay, I exactly covered the year in the other video. Okay, so you just need to, this is a Postgres command. I think SQL server, it's pretty straightforward. You just need to put month and then column name. Here you need to say extract. Okay, year is month. Okay, and then again count of distinct, because here obviously the counts will be there, right? I mean, there are many users it can come multiple times in a month. Like let's say if you were to buy something on Amazon, you obviously do a count, multiple times, right? Like you can place an order 7 or 8 days in a month. So you need to be counted as one only because you are the one user purchasing the item, right? From user underscore transactions and here you need to do group by both. Okay, just copy these commands. Okay, so now what you see, 2021 month 3 18 users are there, 2021 4 2 users are there, 5 2 users are there, 1 2 and for February there's 6. But if you see here, right, they are showing month in numeric. Okay, so month is being displayed in numeric, which basically, we should display it in the January, February and things like that, right? So to do that, what we need to do is, instead of extract, there is uh, uh, another function in Postgres called toChar. Okay, so you need to use this toChar, and then you need to just simply write month. Okay, so what it will do is, it will just extract month from the uh, from it will do the same thing as extract, but it will display the month name, right? That's what we want, right? I mean, we want it by month name. So here if you see, it's actually displaying you the month name, right? It's displaying you 2021 March is 18, April is 2, May is 2, February is 6 and January is 2. Okay, here same thing. So if you don't do distinct, right, see what happens. You have like 18 users in March, right? The count will bump up. So if you see 2021 March, you have 25 users. Why? Because those other 7 users, like they came 7 different times, right? So if you look at that data, it's obviously pretty clear from the data also. So if you see March, right? I mean March 103 user like came 2 times in March, correct? See 29 and 31. 108 came, they are 2 different, but 112 came 2 times, right? So obviously that's why your distinct is very important. Okay, all right, so that gives you the correct answer over here, right? January. Okay, now find out yearly active users, display user ID and year of purchase. Okay, oh actually this is not user ID. Okay, it's my mistake, I think. I probably display the purchase date. So user ID now it's display by month and year. Okay, I think monthly active users display year and month of purchase. Okay. Same thing, display the year of purchase. Okay, because if you do, you can do by user ID also, but then it doesn't make sense, right? Like it's active users, but I mean, if they give you a question where give me the users also, right, which are user IDs which are coming each month also, then you can put user ID there. Okay, and for year it is straightforward, right? I mean, you just need to remove month. You need to remove month from that, right? So if you remove month, then it will just group by month, correct? It will just group by, sorry, it will just group by year, correct? So whatever you put in here, it will group by that. So in this query, it group by month. Since we are removing month from here, it will group by year. Okay, so it is doing group by year. So 2021, 90 and 7. Again, you have to do distinct, because if you were to see the rows, total rows are 37, but here if you sum it up, it's like 26, because obviously those 7 8 users came multiple times in in different months, right? Same thing, like a user can come multiple times in different months. So here, since they are saying yearly active user, right, I mean, so I can purchase the item from Amazon like every month, right? So if I purchase all the months, like I should not be counted 12 times. Be counted once, because because the division or group by, not division, the group by is happening by year, right? So that's year. Okay, so uh, so like we all covered like daily, monthly and yearly. So what we learned is probably group by, right? Group by and different levels. So your extract and then to care is the function we learned, right? I mean, so if you want to display the month name and not just month number, you need to use the to care function, and then yearly obviously group by year. So these obviously, as I mentioned, these are the common questions that can obviously come up because they want to gauge, right? I mean, you can have a trend of yearly, monthly, or daily. The other thing that can come up is show me the growth of the users, right? Every month over month, year over year. And I'll try and cover the video on that as well, right? I mean, that's also important, right? Especially social media companies. If you see, it's very important for them that every year and every month they see the user growth, right? So they can sell more and more advertising, right? I mean, more users you have, more advertisement you sell, more money you make, right? It's pretty simple. So definitely they want to gauge your knowledge on all these things, like you can do analytics on this or not, or you can do the trend on this or not, right? I mean, so it's pretty important question. So let me know if you have any comments or if you have any questions on this. And that's it for it today, guys. Thank you.
Data BI SQL. In today's video, I'll be covering uh, the question related to the user transactions table. So this table I've used in my previous video as well. So if you're not already looked at the video, please go and check it out. Also, I'll be adding this video to the Amazon SQL interview questions playlist. So I'll just put a link on playlist as well. So this is a part 9 of that series. So you can check out all my other videos as well on this playlist. So let's get started. And before we get started, right, I just request you guys to please subscribe to my channel and like my videos. That will give me a lot of encouragement to create this kind of videos. Also, I will put the DDL script, right, create table script and insert into data script for this table, so that you guys can also practice the same way that I'm showing the queries. Also, the other feedback that I'm getting from you guys is, can I write a query like this? Can I write a query in different way? Definitely, you can write the queries. Everybody has a different style of writing queries, right? And different query way of writing queries can yield the same result, right? Uh, but just make sure that you don't impact the performance when you are dealing with large set of data. So here we are dealing with very small set of data. So different ways of writing query may not show you that much of performance gap. But when you're dealing with like millions and millions and billions of rows of data, it definitely impacts the performance. So just like I have covered another video called what performance SQL performance issues related video, just go and check out that video as well. Make sure you avoid subqueries wherever possible and just write common table expression, right? So things like that you need to take care. But I appreciate all the feedbacks you guys are giving me, right? I mean, that way we all are learning together, right? And then everybody can learn different ways of writing queries. So this is very interactive sessions we have, like through comments. So I really appreciate you guys looking at my videos and then writing your own queries and then asking for suggestions. So thank you very much for that. Let's get started with today's video. So the question is, write a query that will identify returning users that have made a second purchase within for 7 days of any other purchases, right? So what they are saying is basically, uh, if any of the user, right, who have done a purchase within 7 days, right? So then you should display that user ID. So for example, if you see 103, he's done a purchase on 29 March and 31st March. So there's 2 days gap, right? So uh, he should he should come up, right? So excuse me. So and then if you see 108, it's 12/5 and 18/3, right? So it's basically a gap of 2 months. So it should not come up. If 103, let's say you had one at 29 March, one at 10th April, that would have been a gap of more than 11 days or 12 days. It should not come, right? Because they are saying that within 7 days, if the person has come back, just display that username, user ID. So you just, if you think from a retail company perspective, right? Let's say Amazon or any other retail company, or if you think from a social media company perspective, also, this is very important matter, right? Very valid business scenario, correct? Because you want your users to come back, right? I mean, you don't want people to just come to once to the platform and then just go away and come back after a year, right? I mean, that's not going to help grow your revenue. You want people to repeatedly come back to your platform, purchase the items, right? And that's how you are going to grow the revenue. So this is a valid scenario where they're asking,
that just show me the users who are coming back within 7 days of the purchase, right? I mean, they are doing a repeat purchase. So since we have to we have only one table, and then they're asking to compare the data within the same table, right? So they are saying that find out the users we are coming back based on the purchase date within 7 days. So that should click in your mind that it's basically a self join. You need to use self join because you have only one table. You have to compare the data between two dates, right? So how are you going to do that? The only way you can do that is to the self join. So here we'll use the self join, user transaction and user transaction, and then we'll join based on the user ID, and then we'll say ID not equal to ID, right? I mean, and we need to use this clause. If you have looked at my other self join videos, right? I mean, where we use self join, we have used this clause, and I'll come back to that. What happens, right? If you don't use this join, right? This condition, but just make sure that you use this condition, right? And then we'll say purchase date, the gap between the purchase date, the A minus B purchase date is between 0 and 7, right? So between clause we have to use. Then order by. So if you see this, 103 is what already we saw, and then 112, 120 is also there. So let's say 112 makes sense or not, right? So if you see 112, 23 and 24, right? So it came back within a day's time, right? That's a valid scenario. 122, if you see three times, right? 2, 3 and 3, 2, this is not, this is a gap of 1 month. But then if you see 3, 7 and 3, 6, which is basically 6th March and 7th March, which is basically a gap of only 1 day. So that's why it should come up. So our answer is correct. Okay. Uh, if you see here, like let's say what happens when we don't use this clause, right? Then what happens is it's not going to show you the correct result. So what it is showing, it is actually displaying all the users. So if you see there are 19 rows, right? So how to see whether it is displaying all the users? We can do a distinct, right? Distinct user underscore ID. So if you do that, then what happens? See 19 users. So basically it is that the condition is not we need to put that condition. If we don't put that condition, then it's going to show the all the users, which you don't want, right? So just make sure to use this condition. Okay. Now the question is, so if you look at the day format, right? I just want to cover one other scenario, right? This is same question, but another scenario. So if you see, let's say we need to do a star. Select star. Okay. So select star. If you see the date, purchase date is in a format where there is no hour, minute, second captured, right? So let's say if this was 2021, 318, 5 p.m., 12 minutes, 30 seconds, for example, right? So if that is the date format, then this query will not work because that you need to take care of the time format also. Here that's not the case, but just in case that's the case, what you need to do is you need to extract the date from that time. So you need to basically, if you see the purchase date, there is a command, and then you are basically extracting the date from that. So in that case, this case, it's showing the same date because there is no hour, minute, second, right? So, but if there is hour, minute, second, you need to use this. So if you see in the where clause, the query is same, but you are basically using this clause, right? Where purchase date, and then you are doing this date minus u1 dot purchase date, again converting in date, and in between 0 to 7. Okay, just make sure to use this clause if you have a hour, minute, second. Okay, so if you run this query, it's going to give you the same result as the above query. Okay, all right. That's it for today, guys. Thank you very much for a lot of interaction through the comments. I'm really liking it that we are having a very interactive dialogue through the comment section. And if there's anything else you want or you have any questions, please put it in the comment section. I'll reply to those questions. Thank you very much, guys. Welcome back to my channel, Data BI SQL. So in today's video, I'll continue with the series of Amazon interview questions. And today's interview questions is right. I mean, it's very tricky and very complex, I would say. So this is definitely probably qualifies for the very advanced level
or at least an intermediate level interview question. So these kind of questions, right, will most probably be asked for the senior roles, right? So senior BI engineer or senior data engineer or even senior data scientist, because it's basically if you structure this kind of questions in your mind, right? I mean, just read each and every sentences and then see what they are asking for and look at the table structure. Then it will make it very easy for you, and we'll cover that because in this one of the clause that they have also mentioned in the queries is just to confuse you. It's like just to put more pressure on you, as in not pressure, but just they want you to think, right? How will you handle that? So it is definitely a complex query. If you look at the query, final query, actually, when I started building the query, if you look at the final query, it's pretty simple actually. But you have to put your thought process. If you have worked on SQL, right? I mean, you will be able to structure this and step by step. But just wanted to bring this up, this kind of questions, because it is tough actually, because what happens is when there are 4 or 5 tables presented to you, and then you have to get the data out of that. You need to think like how you are going to join, and how and what will be the output, and look at the question and all, right? So we will go through that. So before I start my video for today, right? I mean, I just wanted to request you guys to please subscribe to my channel, and please like my video. And that will encourage me to make more videos, right? So let's get started. So in today's question, so what is the question? So first of all, they have given 5 tables, okay, and we'll go through these 5 tables. So let's go through the 5 tables first, and then look at the question, right? That's that way you understand the data and understand the questions also, right? So the first table is contest. So what happens is there is a contest ID, then there is a hacker ID, and there is a name, right? So there are only 3 records here, if you see. And then there is a colleges. Okay, so when you say colleges, so if you see there is a contest ID here, right? And then there is a college ID. So obviously each college will have a contest, right? So if you see both the tables, right, the contest ID is common. So that should click your mind that there'll be a join involved somewhere here, right, with these 2 tables. So the college ID and contest ID. Then you have challenges. So in challenges, you have challenge ID and college ID. Again, if you see the college ID over here will join to the college's college ID, right? So that it's basically, it's joined between different tables, right? That's very important over here, and just putting in your mind how the joins are going to work, right? That's also very important. So college ID, if you see there is one challenge ID, and each college ID can have a different challenges, correct? That's pretty straightforward. Then you have 2 fact tables. So view stats. See view stats for each challenge ID, they have the view stats. Okay, so total views is 26 and 15, and unique views is 19 and 14, right? So there are total views 26, but unique view is 90. Okay, so for each of the challenge ID, there are this view. So again, challenge ID will join back to the challenges table, right? So if you were to describe this, right, I mean, what schema? If you were to describe this is kind of a snowflake schema, right? It's a normalized schema. There are 2 tables which has a challenge ID, right, joining to the challenge ID. Then challenge ID in turn joins to the college ID, and college ID in turn joins to the contests, right? So if you have not already looked at my video of star and snowflake schema for the data warehousing concept, I do recommend you to go and look at that, right? I have a playlist also for data warehousing. So I request you to go and look at that, because that's very important, right? I mean, if you get that concept, then it is very easy for you to understand this kind of questions, right? Because immediately when I looked at the table structure, I thought, oh, this is a snowflake schema. That's how they are basically joining the table. So I think it's very important to have the core concepts clear, right? Because eventually that will also be asked, like, the last star schema is better, snowflake schema is better, or the star schema or snowflake schema, what's the design and things like that. So I mean, if you're attending the architect interview, right, senior data architect interview, then those kind of questions will definitely be asked. So I do recommend you to go and look at that. I put a link in the comments for that video and the playlist as well, so that way you can go and refer to that. But this is definitely a snowflake schema. And if you look at and then you look at the final table, the challenge ID is again presented here, right? So for each challenge ID, what are total submission, and out of that how many are accepted submission, right? So total submission 34 but accepted only 12. Correct. So again, challenge ID joins to the challenger table, right? So these two are fact table, and then there's a dimension table, 3-dimension table, right? Okay. Now let's look at the question. So John interviews many candidates from different colleges using coding challenges and contest. Okay. So challenges table and contest is a contest, right? Write a query which displays the contest ID, hacker ID, name, sum of total submissions, total accepted submission, total views, and total unique views, right? So we just saw that, right? I mean, there are total submission, total accepted submissions in this table, submission stats, and then total views and total unique views is in view stats, right? So it's so here one thing very good is the aggregated columns are already stored in the table, right? Because the columns just stored, they are just exactly asking that, right? So you don't have to, do any you don't have to do anything from your side, right? I mean, aggregation or you have to do aggregation. Obviously, you have to do summation because you can have one challenger ID, one challenge ID, two challenge ID in this table, right? So it has to sum up the data, correct? Of both this, right? Submission and accepted submissions. But they have given the straightforward column, so that's a very good thing, right? So that you just need to keep that in mind, and then go and look at contest ID, hacker ID, name is in which table. So if you look at the tables one by one, the contest. So all three columns are in one table. That's very good, right? I mean, so first thing, just focus on the select clause from where the joins are going to come, right? I mean, sorry, where the select columns are going to come. So contest table, view stats, and submission stats, right? Very clear. Now, second thing, think about there, can we join context and view stats directly? Answer is no, right? Because there is nothing common between them. How will you join them? What we saw in view stats, we saw challenge ID in view stats, correct? We saw challenge ID in view stats. So challenge ID is how you join the fact table. Do you have challenge ID here? No. Do you have challenge? So how can you join contest table? You can join it only through colleges, right? Because contest ID is only in the college ID. In the college ID, if you have to join, where you need to go? You need to go to challenges, correct? So basically, you know, if I have to go to contest, you have to go through these three joins. So basically, you have to join every tables, right? Because that's how there's no that so that's how the snowflake is, right? So sometimes that's why we don't prefer snowflake schema, right? Because as you see here, you have to do join. So if you do more joins, obviously your performance will slow down, correct? So that's why that's another interview question. Will you prefer snowflake or star? Answer would be mostly star because that will reduce the joins, right? But in this case, they have already given us the table structure and all, so they probably will. But we understood that in order to get all the data, we have to join everything, right? That's one thing. The column, so column and select clause and from clause is now sorted. Now what they are asking is exclude the contest from result if all four sums are zero, right? So and sorted by contest ID, okay? Sorted by contest ID. So you need to order by contest ID, okay? Just make sure, okay? And then from the result, if all four sums are zero. So what they are saying is actually, if you see the data they have given, this clause, even if you don't put, that's fine, but that's what they are saying, that all four sums are zero. If all the four sums are zero, then don't basically exclude that. Okay, so what does that mean? If one of them is not zero, include that, correct? So that's why what you need to do is you need to filter clause. You need to have total submission is not equal to zero, or accepted submission, or total views or total unique views not equal to zero, right? So what does this mean? It's or condition means if one of them is one more than zero, it will get included, correct? So that's your so you sorted your select clause, you sorted your filter clause, and you sorted your order by clause, right? Now we need to comes the join clause, right? So all the columns that are asked, we got it, right? We have to join contest with the college on a contest ID. We have to join challenges and colleges, right, on the college ID, right? That's what we discussed. That's how you will be able to join to the fact table, right? Now, after that, these two columns are coming from one table, correct? Total submission and accepted submission, right? That's from submission stats table. And then the views column is coming from the view stats table, correct? right? Both. So what we need to do is we need to get these two columns and form a and treat it as like a table, okay? And why I'll tell you, because we need to a left join, okay? Because null records are there, sometimes coming up, right? I mean, it will come up. I'll show you, and that's why you have to do this, okay? You have to just treat to get those tables. So what we are doing is here we are taking challenge ID, sum of total views, sum of unique views from the view stats table group by challenge ID, right? We are doing the by challenge ID, we are getting it. Why challenge ID? Because we have to join based on challenge ID, right? Remember that we have to join these two fact tables are joining to the challenge table on the challenge ID, correct? That's why we are grouping by challenge ID, correct? So if you see on challenge ID, again left join the second table, again challenge ID, right? See again challenge ID we are doing, and we are getting other two metrics, right, based group by challenge ID, right? So so excuse me, so basically what we did is we joined the simple joins for the dimension table. With fact table we are going to do the left join, okay? And I'll come to that left join, right? So entire data set is taken out, right? I mean, entire data set is formed now, right? And you have to group by contest ID, hacker ID, con name, because that's what they are saying, right? To display the data by, right? So already telling you that display this data based on contest ID, hacker ID, and name. Show that, right? So obviously, when you have to show that, you have to group by that, right? Because without that, it will not work, right? You need to include that in group by clause. So here, let's just run this query, okay? So if you see contest ID, hacker ID, rows, name, and 111, 39, 156, 56. So that's basically sum of all these things, right? Total submission, sum of accepted submission. So we can say this as total underscore submissions, right? I'm just going to just rename one, but you can rename all of them if you want, right? So it's a total submissions, right? So okay, just remove this. So that way it is giving you the data you want, right? Now why we need to do left join? Because let's say if we don't do the left join, okay, we just do a normal join, then let's see what happens. Because these two records are null, right? For Angela, right? For Angela, this total submission and sum is null. If we remove the left join, the Angela's record should most likely be dropped, and which we don't want, right? See, because Angela's record will be dropped, right? Because two of the sum that we did had a null value, correct? It's a null value, but still we have to show the other two value, correct? Correct. The other two, that is total views and so Angela had total views and total unique views, but she did not have any submissions and accepted submissions, right? And here, why the data is also coming up, because if you see the clause, right, that we are saying 0, 0, 0 or condition, right? In this case, these two are zeros or, but these two are not, right? So that's why we need to bring up that record, correct? So that's why we need to bring up that record, okay? So that's where I, we have to do a left join, right? So so in this case, right? So if you see the final query, right? Even it looks big, but if you have gone a structured way based on the question that is given to you, finally you were able to solve it, right? So first was like determine the select clause, determine the tables, look at the structures of the table, see where the joins are going to happen, get the needed columns, right? Define the where clause, define the filter clause, right? And then define the order by clause, and then form the entire query, right? And get the data, right? Now the reason I was saying is this particular clause, they are saying that result if all four sums are zero, right? Exclude if the result was, that's just to trick you and just to test your knowledge on having, right? Because here you have to do group by. So they want to see that how do you include that in a filter, right? I mean, are you going to, probably how are you going to include the like, are you going to use a where clause, or are you going to use a having clause? Because here you have to use having clause, right? Because you are doing summation, right? You are doing group by and summation, so you have to use having clause. So that's also a test of your basically test of your skills, right? I mean, So if you just were to run this, right, group by clause, then also the answer remains same, right? That means there was not a condition here which satisfied this, right? Okay. So that's why I'm just saying that they wanted just to trick you and test your knowledge, right? And how are you going to solve that? When they are saying that, if all results are sums are zero, right? Exclude that. So they want to know that how are you able to solve it, right? By putting it in having clause, and are you able to solve it by you putting or clause? Because if you put and here, you can't put and here, right? Because one of them comes true, then then you have to display the record, right? That's why you have to put a or clause, right? And then they're asking you to do order by also, and then they are asking you to get the complete data, and then we have to do a left join, right? Like you saw, if we don't do a left join, this record will get dropped, right? So it's basically, if you see, lot of it's basically testing of lot of knowledge, right? I mean, first of all, are you able to write subquery, right? So this is nothing but a kind of a subquery, as in, it's not a subquery, but it's kind of forming a table, right? And then doing a join with that. What join knowledge they are testing, inner join, left join, right? And they are testing your group by knowledge. They are testing your group by having knowledge. They are testing your filtering knowledge. They are testing your or end condition knowledge, right? And then they are finally testing your order by knowledge as well, right? That's why they're saying order by context ID, right? And then they are testing your, obviously, the overall structure or architecture knowledge, right? In this, if you see, they have tested your star schema, snowflake schema knowledge also, right? Because if you don't know that concept, it's going to be difficult for you to figure out the query, right? The moment I saw this particular tables, first thing it came to my mind, what kind of schema is this going to be, right? And immediately when I saw contest is connected to college, college is connected to challenges, it's a snowflake schema. So it just clicks you, and then it makes basically the thought process very clear. Excuse me. And then eventually makes it your query writing skill also clear, right? Uh, so this is the complex query, right? I mean, so I will include the scripts, right? Insert script and create table script and insert script, so you have the same data that I'm looking for. And then I'll include this final SQL query as well, so you guys can also practice it from your side. I hope this video was very useful to you. And please do subscribe to my channel and like my videos. That gives me a lot of encouragement to make this kind of video. Thank you, guys. Back to my channel, Data BI SQL. So in today's video, right, I'll continue with the Amazon SQL interview questions series. So I have already made 10 videos on this and on the SQL interview questions from Amazon, and then this is the 11th video. So I will put this in a playlist. I have a playlist for that as well. You can check it out in the link in the description. And then just look at this video, I would say, pretty carefully, because there is a high chances that this kind of question will come up, in the interview question. And this is the intermediate to advanced SQL question. This is not a basic SQL question. So you can expect this mostly in the senior BIE interviews, senior data engineer interviews, and senior data scientist interviews. Because the query, if you look at it finally, it might look simple, but the thought process that goes in this, right? I mean, it's not simple, straightforward. You need to use common table expression. You need to think through how the data is structured and things like that. So it's an advanced level, I would say, interview question. Please pay attention to this. I'll share the DDL. I'll share the insert statement. I'll share the select query we are seeing here. So you guys can practice it on your own by downloading the Postgres and pgadmin, right? I mean, that will help you. So before I get started, right, I have a request that please subscribe to my channel and like my video, so that gives me a lot of encouragement to make this kind of video. So let's get started. So here, if you see, there are two tables that are provided, okay? So pretty straightforward: employee table, city, name, right, and salary. For this video, we just need employee ID and salary, because the other columns are not into picture for the questions being asked. So just look at this employee and salary. Straightforward table: employee 1 making 150,000, 2 making 200,000, and so on. There are 10 employees. The second question is, sorry, the second table is, it gives the relationship between the employee and the manager.
right? So employee and the manager relationship, typical, right? I mean, you have multiple employees reporting to the same manager. So if you see here, employee 1 reporting to 4, 2 and 3 reporting to 5, 6 reporting to 4, 7 and 10 reporting to 4. So one manager, employee 4, having a 4 reportees, right? So pretty straightforward. So what's the question? The question is write a query to display those employees who are making higher salary than their managers, right? So we need to print those employees who are making higher salary than their managers. What does that mean? So if you see employee 1 and employee 4, if you go and see the salary of employee 1, the salary of employee 1 is 150,000, salary of 4 is 340,000. So is employee 1 making more than employee 4? No. So employee 1 will not come up. Let's look at employee 4. Employee 4 is making 340,000. If you see employee 4 is reporting to employee 7, which is making 250,000. So employee 4 will come up because he is making more than the uh, employee 7. So if you see the relationship, right? Let's look at the map employee hierarchy. So 4 is reporting to 7, right? So 4 is making 300,000. Then 40 employee 7 is making somewhere around less than 300,000. So that should come up, correct? That should come up. Okay. Uh, yeah. So 4 is 340, 7 is 250,000. Okay. So I just put it just for a simple understanding, right? So employee 1 and 6 reports to employee 4, and these both employees make less than 4, and these make less than 5. So this should not come up. So all these employees should not come up. Let's look at 4. Okay. 4 reports to 7. So this should come up, right? Because 4 is having 340. We just saw it, right? So 4 should come up. 5 reports to 8. So 5 is 300,000. 8 is 300,000. Uh, so it should not come up, right? Because both are equal actually. So that's why they said just higher salary, okay? Not equal to also, okay? So it should not come up. And 8 reports to 9. So 8 is 300,000. 9 is 270,000. So it should come up. So our answer should be 4 and 8. So now how do we solve this, right? How do we go about it? So here what is there is probably you need to compare the salaries between two different sets, right? You need to compare the salary of a manager and you have to compare it with the employee salary. So when this kind of comparison things come up, right? And I have covered this common table expression in video, I think 3 or 4 and other videos as well. So if you see my revenue growth video, right? I think that's video 8, 9, or 10, 7, 8, 9, I think, one of them. Over there, the revenue growth, when we are comparing between 2021 and 2020, we came out with the same kind of concept, like get the data for 2021 revenue, get the data for 2020 revenue, and then compare the growth, right? So here, same thing we can do. So what we can do is so this is called common table expression in SQL and this advanced concept. So what we'll do is we'll bring up two tables. Okay, so first table is with employee underscore cell, right? So when you run this query, pretty straightforward, bringing the salary employee, right? Employee 4 making 340, employee 1, everybody, like, we are just bringing the employee salary. Okay. The second is where we are joining this to table and we are bringing employee salary, but we are bringing manager ID also along with that. Okay. So if you see here, employee 4 is reporting to employee 7. So that manager is coming up here, right? Why we are bringing manager? Because we need to compare the salary of manager, right? How much a manager as an employee, manager is also an employee, right? So we need to compare the salary of manager and that with the employee, right? So here, if you see employee 4 is reporting to 7 and employee 4 is making 340, 7 is making 250. So we'll just do that comparison and say that when 4 is greater than salary is greater than 7, then print the employee 4. Okay. So here, so now the next query is, if you see, we're bringing employee ID. We are joining these two tables that we created, employee underscore cell, manager underscore cell, and then we are joining the employee ID of this employee table with manager employee ID of this table. Okay. So what it will do is it will join the 7 and 7 here, 7 as a manager. Okay. For 4, let's just look at the employee 4 because that's what is going to get printed in the output, right? So that's why I'm just concentrating on 4. You could obviously, I'll put this queries in the description. You can play around with the query. You can see the data yourself, and then you can tweak the queries, right? I mean, you can do all those things, but here let's concentrate on 4. So when you say the employee ID 7, right? And here the manager ID is going to be 7 for 4, correct? Right? So it's going to join 7 with 7. Okay. So here what we are saying is, here the salary, right? When you are saying employee 4 salary
is greater than employee cell dot salary. So what we are doing is, remember here we are joining with the manager employee ID. So what it is doing is it is comparing the salary of 7 with that of 4. Correct? Correct. So it is here we are saying employee salary. So here remember we are joining manager employee ID. So manager employee ID is what? 7, right? A manager employee ID is 7 for employee 4. So we are joining that with this. We are getting the salary of, here the salary of 7 will come up, and here the salary of employee ID. So here is the salary of 4 will come up, right? So we are saying when the salary of the employee 4 is greater than salary of employee 7, who is a manager of employee 4, print me that output, right? So compare employee 4 salary, which is 340,000, compare employee salary, which is basically employee 7, whose salary is 250,000, and if it is greater, then print the output. Okay. So let's just see the data, right? So if you see, if you run this query, you need to run that together. So you're getting 4 and 8, correct? Now, if you do less than, then what should be the output? That means you are saying, bring me all the managers that are basically making more than the employees. So what will happen? 4 and 8 will not come up, correct? Because 4 and 8 came up when as employee they are making more than the managers, right? Here we are saying bring me the managers who are making more than employees, right? So 4 and 8 is not coming up. And when we do it equal, what happens? What should come up? Employee 5 should come up because their salary is 300,000, both of them, correct? See, so that verifies that our output is correct basically, right? So for the question that we had is we had to get the employees whose salary is more than the manager salary. So in that case, 4 and 8 is coming up. So that's the correct output. Okay. So if you see, when we structured the queries the way we wanted, like based on the question, it made it simple actually, right? And that simplicity came from, okay, the comparison is being asked, right? So should we do a self join, or can we go with a common table expression? Okay. So in this case, we went ahead with the common table expression because we're comparing the salary of the manager and salary of the employee. So bring two tables, bring the manager ID, join the manager ID, manager employee ID with that of employee ID for the employee table, right? And then compare the salary between both the employee and the manager, and that way get the data, right? So this is definitely a tricky, as in when the question is presented to you, you need to think like how we are going to write the query, right? First, you need to structure what should be the output, right? 10 employees are given based on the query and the data, and data is very straightforward, right? 10 employees. It's not like they gave you 1,000 employees, right? They just gave you 10 employees. So, okay, the question is employee making higher than the managers. Let's go and look at the salary of, let's first look at who is reporting to whom. Once you figure that out, and see which employee is making higher than the manager, right? So just bring your output down to 2 or 3 employees, right? In this case, just in your mind, right? So these two should come up. So you should concentrate on that. So once you know the output, that this should be the output, it makes it a little bit easier to write the query, right? So just structure it like that. So uh, so that's it for today, guys. As I mentioned, I'll share everything in the description of this video. I'll add this to the Amazon interview question playlist as well. There are other 10 videos, so total it will make 11 videos with this video. So request you to go through all the videos, if you have not already watched. All of them are covering different kind of concepts, basic to intermediate to advanced concept. And I want to thank you all very much. Back to my channel, Data BI SQL. So in today's video, I'm going to actually continue with the questions that I covered in my previous video. So I just thought that if you looked at my previous video, video number 12, or sorry, video number 11, this is going to be the video number 12. So video number 11, if you have seen, I've covered a very important question, right? And I covered it through the with CTE, right? With common table expression, right?
So I just wanted to cover the answer for that question in a different ways also using self join, because I think it's very necessary to know there are different ways to write a SQL, right? I mean, and this is the classic example where I wanted to show that on top of the CTE, with CTE we can solve it through a normal query also using self join, right? Kind of a self join. So I will repeat the question once again. Just a short summary. But if you want to see the whole question and the entire data set I have gone through, right? Please refer to my video number 11, right? So let's look at it. So there are two tables. Employee table is having employee name, employee city, date of birth, pin code, and salary, right? And then you have map employee hierarchy, which is basically your employee ID and the manager employee ID, right? So the question is, write a query to display those employees who are making higher salary than their managers, right? So as we saw in that video that if you see this table, employee 5 reports, employee 4 reports to employee 7. So 4 salary is 340,000, 7 salary is 250. So 4 should be displayed, as well as 8 should be displayed because 8 is reporting to 9 and 8 salary is 300,000, 9 salary is 270,000. Rest of the other employees are basically are having a less salary than their manager salary. So our output, expected output, is employee 4 and employee 8. And in last video, if you see, we have how we have covered is, we have covered employee salary table where we get the employee salary, then we get a manager salary, and then we compare it both, right? Manager salary should be greater than employee salary, right? I mean, what I mean is basically the salary of the employee, right? The question is the salary of those employees who are making higher salary than the manager. So we created two tables and then try and compare the salary of an employee whose salary is greater than their manager's salary, right? And we came out with the answer. So if you run this query, and I'm not covering this in detail in this video because I already covered this in the video number 11. So if you see this, employee 8 and 4 are the output, right? So now let's get to the second option. So second option is using the self join, right? So how using the self join? So we need to cover. So what we are doing here over here is, if you see, we are first joining employee with basically the map employee hierarchy using the employee ID. Okay, so that's basically to get the manager. If you see here, right, we are getting the employee ID. So what we are trying to do is, and this is a little the simplest way to solve it, rather than going through the which city, because this is pretty straightforward. And that's why I thought of making a video on this, that if you don't want to go the which city route, everybody has a comfort. Some people are comfortable with which city, so you can go that route as well, if that is clear in your mind. But if not, then you can use this query. So what we are doing here is, we are joining employee and employee hierarchy table. What we are doing is employee ID and then employee ID, right? So we're joining employee ID. What we are getting here, see, we are getting employee ID and then we are getting manager employee ID. So employee is manager, right? And then we are getting a dot salary. So basically employee salary. And then what we are doing is, we are joining this data set with again employee C. Okay, again employee table. So it's kind of a self join, but what we are doing is, we are joining employee with map employee hierarchy and then again joining the employee, right? But we are making this as a C. Why we are doing it? Because if you see the difference here, in the first set we joined employee ID using employee ID. In the second set, what we are doing is, we are joining manager employee ID with employee ID. So what we are doing is, basically, when you are taking the salary from C, we are taking salary, we are naming it as a manager salary, if you see, right? Why? Because even though we are saying C dot salary, which is basically employee salary, we are naming it as manager salary. Why? Because what we are doing is, we are joining based on the manager employee ID. So basically what we are doing is, we are getting manager salary, right? We are joining the employee ID with that of a manager employee ID of the employee table, okay, not the employee ID. So first set is basically to get the employee ID and their employee salary. Second set is to join with employee table again, and based on the manager employee IDs to get the manager salary. So here, if you see, it's pretty clear, right? Print the employee ID,
print the manager employee ID, print the salary of an employee, and print the salary of a manager who is the manager of this employee, correct? And then what is the question? The question is the employee salary who are making higher than their manager. So if you see here, A dot salary is employee salary is greater than C dot salary. Yes, C dot salary is manager salary, right? That's our question, right? So when you run this query, it will give you the clear correct answer. And here one good thing is, and the reason why I wanted to cover this is, here we are printing all the salary and all the employee ID and manager ID also, right? So if you see employee 4, employee salary is 340,000. Who is employee force manager? Employee 7. So employee manager salary is 250,000. Employee 8, his salary is 300,000. Employee 9, his salary is 270,000. So 340 and 300,000 obviously greater than the 250 and 270,000, right? So that is the correct answer. So this is the if you see this query, it is little complex, right? I mean little complex to understand, right? Whether you're bringing two data sets and then joining it in the final query, it gives you the same result, right? And some people are wired to write a lot of with CTE, so that if that works for you, but that's best. But if not, then this is the simplest way to join, where you are first bringing the employee salary, then again joining with the employee table, right? Kind of a self join you're doing, again joining with employee table, and then getting and joining based on the manager employee ID, and then getting the salary, the manager salary, right? And then comparing directly whether employee salary is greater than the manager salary, right? So it's pretty straightforward, very clear. You're printing all the columns. When you see the output also, it is very clear that the questions that is being asked, you are answering it correctly, right? So let me know if you have any questions, right? I mean, whenever I come across, right, I mean, where different methods to solve it. When I made the CTE video, after making the video and uploading it, actually I thought, maybe there is a simpler way to solve this, right? I mean, it should not be that difficult. Why I had to go through the CTE route? And then I started writing this query, and then when I wrote this query, I thought it's pretty simple and straightforward, right? And that's why I thought of sharing it. All right, okay. Thanks all then. See you next video. Welcome back to my channel Data BI SQL. So in today's video, we will continue with the Amazon SQL interview question series, and this is part 13 of the series. So if you have already not looked at my other parts, you can go ahead and look at it. I'm going to put this video also in the playlist. There's a playlist for this, so it has all 13 videos, so you can go and look at my other videos as well. But we can go ahead and to the part 13 today. So before I get started, right, I mean, I request you guys to please subscribe to my channel and please like my video. So that gives me a lot of encouragement to create this kind of videos. Excuse me. It's it takes a lot of time for me to prepare the data needed for this queries, and it takes a lot of effort to kind of go through the concept and go through various concepts. So I request you guys to please subscribe to my channel and like my videos. So let's get started. So in today's video, right, and this is very important video, I would say, because it covers like a lot of things, like a lot of filtering conditions, I would say, and then it covers something like date part function, something like extracting the age, and also it covers it'll cover the group by and subquery. So kind of covers all the concepts, which I would say this would be the query that qualifies for kind of intermediate to advanced SQL. It's not a straightforward simple. You cannot say this is the simple level. This is something like medium level. It can be asked in the interviews for senior BI engineers, senior data engineers, and data engineers, and so on. So let's get started. So over here they have given one table. Select a star from customer dim, cust_dim. So it's basically a customer table, pretty straightforward. It has unique customer ID. It has full name of customer, the birth date of customer, the item purchase date. So here you are seeing that they are giving the item purchase date directly in the dimension table, which is kind of little unusual, right? I mean, you will have the item related data, item and everything in the fact table. So, but that's fine here. There is a purchase date, and they have given an item spent amount also. Okay, so basically they are giving that on this date, on an aggregate, this particular customer spent how much of money, like so $1,200 for example, for Lisa Johnson. Which city the customer is living in, what is the state, and what is the country, right? So you can see that there are different countries listed here. So one is US, one is Canada, and one is France, right? So there are three different countries. So let's look at the question. So it is saying that how many customers older than 40 years old by state have spent at least $1,000, right? So what does that tell us? That tells us that basically they are saying that 40 years old uh, by state and $1,000. Okay. When you say at least $1,000, right? So that they are looking for some kind of a filtering, right? I mean that should click your mind. So if you see the amount spent, there are $800, $2,000, $1,400. So immediately it should click to you that okay, 800, 700, 800 are kind of disqualified from this query, right? Like they'll be excluded because it's not going to meet this condition, even if it's going to meet other conditions, right? They are not giving any or condition here if you see, right? So it's and condition and this will get excluded, right? So that's one filter. What is the other filter? The other filter is by state, right? So they are saying it's not a filter, but by state means what they are telling you to group by state, right? So if you see the state, you have Toronto as a state, you have GA as a state, right? You have CA as a state, Texas as a state. So they're telling you to group by state, right? So if you see there are three people living in California, two in Texas, two in Toronto. So basically, by state means it just click to your mind. It's a group by, right? Older than 40 years old, right? So older than 40 years old. How do you know the age from the birth date, right? So birth date is 1980, 1984. So you need to extract the birth date, right? So you need to make sure that 40 years. So you can do you can basically from today till last 40 years. It's roughly basically anybody who is born before 1982, right? That's a 40 years time period, right? So that's also kind of it'll click you that if they are saying that anybody born before 82, the people who are born after 82 are automatically disqualified, right, from this query. So 1984, 1992, 1990, 1988, all of those people will be out. Okay. So let's get started with the query, right? So since they are saying by age, definitely it will need a group by, and they are saying how many customers. So how many customers means they are asking for a count, right? So count of customer group by state, right? So that's kind of straightforward, right? You will probably gauge it from here that they are asking for a count of customer ID by state, right? So let's get started with the query. So for what we can do is first we need to get all the customers, right? So what we'll do is first we'll get all the customers. Let's just get the table name out there first, right? So let's just get the customer IDs and state. So what we are trying to do is we'll first take the raw data here, right? First thing is to get the raw data, get all the customers and their state, right? Along with the filtering condition that is there, right? So from where what they are saying spend at least $1,000, right? So $1,000, how will you get? You need to have item underscore spend underscore amount, right? What they're saying at least $1,000, so greater than $1,000. Okay. And now how to get the age, right? So how to get the age? So in Postgres, there is a function called datepart and there is a function called age. Okay. Why datepart? Because we need to extract the year, right? We need to extract the year, right, from the date, correct? Right? So we need to extract the year because they're asking, right, 40 years old, correct? So what this will do is this will give a difference of, and this will give the year, and age is the function which will give you the age. Okay. So age is the function which provides you the age actually in years, months, and days, right? Because 42 years, 50 days, something like that, right? 42 years, 10 months, 50 days, something like that, right? But here we are looking for only the 40 years, right? We don't care they are like 3 months after 40 or 5 months after 40. Don't care. We just care about 40, right? So we can put a date. We can put a date part function here, then extract the year, and then age is what is going to give you the birth date, right? So age of the birth date, right? That's what we are trying to see. So birth date is here. This is the column. So what it will do is it will automatically calculate the age, right? It will do sys date minus birth date, right? And there is a age function available directly, so why not use it, right? So it will directly calculate the age. So let's see what this gives, right? So if we see this, it's giving the age, right? So what we can do is we can select the customer name also, right? So let's do one thing, and I'll post this scripts also, right? In the comment section. All of you have been asking for the script. So like what is the DDL script, like how to create table script, insert into script, right? So as you can see, I already have this ready, so I'll post it in the comment section. Okay. Full name, date part, correct. So if you run this query, you can see that all of their ages coming up in the in the format that we want, right? 42, 37. So we want only the guys with 40, right? Greater than 40, correct? So what we will do is here we will say, okay, we will say date underscore part, right? Year, okay, and then we will say age of birth underscore date, okay, is greater than 40. That's what our answer, right? That's what we are looking for. Okay. So we got it, right? Anybody who is basically getting $1,000 who have spent more than $1,000, we got the customer IDs and their respective state. So now if you see here, Texas has one customer, Paris has one customer, California has two customers, and Toronto has one customer, right? So now what the question is, how many customers by state? So what you can do is we can make this as a subquery. Okay, can make this as a subquery, name it as A, name this table as A, and then say select A dot state and count, right? Because we want count, correct? Count of customer IDs, right? Okay, and then group by A dot state, correct? How many customers older than 40 years we take care of that. By state, we took care of that. The count of customer ID, we took care of that, and have spent at least $1,000. We took care of that as well, right? So let's why? Because okay, because we are treating this as a table, right? We're treating this particular subquery as a table, right? So we need to put a from clause. Okay. See, California had two, Paris had one, Texas has one, Toronto has one, right? Okay. So that's our answer, right? So what the concept we covered here, we covered the concept of group by, we covered the concept of count function, right? And then we covered the concept of subquery, because this is a subquery. We wrote a subquery first, right? And then we got it from there, right? We put it in the subquery and then we got our final result. We covered the various filtering condition, and then we covered the age part, right? How can you extract the year of number of years for the age, right? We covered the age function and how to extract the year out of that, right? No, how many years old, right? So that's what we covered. Okay. Now this can even be they can even further expand this, right? So if you see this, if you saw the data, they said it has different conditions. So they will say how many customers older than 40 years old by state have spent at least $1,000 and residing in and residing in US. Okay. So what does that mean? That means that they are looking for only customers which are in US, correct? So what we need to do here, again, we need to put and country is equal to US, correct? So now if you further put this filter, what you get only three customers, right? Because other were Toronto and France, right? So that's why you have to those will get excluded. Okay, so you have two from California, one from Texas, right? So once if you run this query again, what you will get is you'll get California to Texas one. That's our answer. Okay. Yeah, so yeah, it's if you see when we built the query and completed the query, it looked simple, right? I mean, we just created a subquery and then we did a count function out of that. But when the question is given to you in the exam, right? I mean, in the sorry, not exam, but let's say in the interview, right? So you might get confused, that how many conditions are there, right? I mean, how many conditions are being asked for? But just keep a cool mind, I would say, like I have mentioned in my other videos also, just try and understand the question, look at the table and data, and then try and put it in your mind first, like what all things are needed, right? I mean, try and structure the query in your mind, right? I mean, what all things are being asked for, and go one by one, right? So, how many customers means count function, by state means by state to group by, so this count and group by will go together. Older than 40 years, but date is given, so that means it's a filter. Have spent at least $10,000, sorry, $1,000, that means it's a filter. And residing in US, the country column is given, and in US, that means that's also again a filter. So when you have this kind of a structure in your mind, right? I mean, we will have three conditions: the filter, and then we need to have a group by state, and then we want to have the count by customer ID, which of these two will go together, right? In a group by and the count, right? I mean, state and count will go together. So once you have all these things, right? I mean, placed together, right? I mean, it became so simple to write the query, right? So just keep your mind cool, structure the query, and then go from there. So that's it for today, guys. I hope that today's video was very useful to you guys, right? I mean, I want to thank all of you for all the supports you have shown till now, and I get very good and positive comments in all the videos, and please keep up that. I definitely want to know the feedback from you guys. So I again request you guys to please subscribe to my channel and like my videos. That's going to give me a lot of encouragement to create this kind of videos. Thanks, guys. Welcome back to my channel Data BI SQL. So in today's video, right, I'll continue with the series of Amazon SQL interview questions. And today is the part 14 of the series. So I have already made around 13 parts of this series. So I'll add this particular video in the playlist related to Amazon SQL interview questions. So this will be the part 14. If you have not already seen my other part 13s, I definitely encourage you to go and look at that. There are various concepts covered in those videos along with the data examples. So we'll continue with the series. And then this video is also very important, I would say, and these kind of questions are mostly asked, I would say. These are the questions which are definitely asked. There is a high probability, I would say 70 to 80% probability that these kind of questions will be asked. So let's just go through the couple of questions today. Before I start, right, I mean, I request you guys to please subscribe to my channel and like my videos. That's going to give me a lot of encouragement to prepare more of this kind of content. So let's get started. So and one other thing, like, I'm going to put the create table script and uh, create table script and also the insert into script in the comment section of this video, so that you can recreate it from your side, and you can play around with the data, you can play around with the query, and you can build the own query, and you can build the same query as I am building. So that gives you a lot of practice. So one other thing, okay, let's go ahead. So in this video, we'll be covering two tables. So one table is cust underscore dim table, which basically we covered in the part 13. So I'll just run the query for this also, so that you know what the data is, in case you have not seen the 13 part 13. But we have a new table, order underscore fact, in this video. I'm going to share this create table and insert table scripts in the comment section, so you can just directly copy paste and run it on the PostgreSQL, and then that table will be created, and then you'll have the same data as I'm showing also. So let's go through it. So there are two tables. Okay. So first table is customer underscore cust underscore dim table. Pretty simple, right? I mean, you have customer ID, you have name of the customer, birth date, item purchase date, item spend amount, city, state, and the country. Okay. In the order fact table, you have customer ID, order ID, right? So for each order ID, who was the customer, right? So obviously one order is placed by only one customer, so it's one-to-one relationship. And then you have the order date when the order was placed, and you have order type. So type is basically the order was placed through web, it was placed through mobile, or it was placed through the customer service, right? I mean, what was the channel basically for that order? So as you can see here, there are orders which are basically same order is placed by, I mean, different order is placed by same customer. That is possible, right? So it's basically one-to-many relationship, right? I mean, one customer can order as many items as they want, and as many orders as they want, right? So if you see here, there is one customer, one, two, three customer who have like more than one orders, right? So 8, 9, 10. Okay. And when we look at the table structure, right, it's pretty clear that you can join the customer dim table with order underscore fact table using customer underscore ID, right? That's a unique column between, not unique column as in, that's a column where the join can happen between two tables, right? So it's pretty clear from these two table structures. All right. So first question is, which customers in Texas have made a purchase, right? I mean, so which customers in Texas have never made a purchase? Sorry about that. So what they are saying is, there are customers which are basically in Texas. Find out those customers which have never made a purchase, right? So basically what they're saying is, so you see here how many customers are there in Texas? There are two, one customer three and customer five. So what they are saying is, which customers in Texas have never made a purchase, right? So what do they mean by that? What do they mean by that is basically, do you see any orders for those customers that are living in Texas? So if you go through here in this one, so you can see that 3 and 5 are there, right? So 3 has made an order, right? And through web, but you see 5 here? No, you don't see 5 here. So that means they are looking for the customer number 5, right? Who is existing in the customer table, but who has never made a purchase, correct? And we want to put only Texas, right? So what clicks in your mind? The first thing that should click in your mind is basically the state is Texas is where the filter, right? Because they are asking for only Texas people. So that's why you should have that in a end clause. Okay. And then so the query is kind of look like is basically, so here we are going to use subquery, right? So first of all, what they're asking for, which customers, right? So where the customer is there, name of the customer is there in the customer dim, right? So we'll say customer underscore ID, full name from customer dim, where c underscore cust ID not in, right? Because see, when you run this query, what will happen is it will select all the customers which exist in the fact table, right? Order fact table, right? Because that's what they want, right? They're saying that find out those customers who never have made a purchase. So if you want to find that out, you need to first get the customer ID from the fact table, right? So if you see here, 5 is not there, right? 5 is not there, 9 is also not there, but 9 doesn't belong to Texas, right? So that's why our answer should be 5. So and I think 9 is belonging to Canada or France, or we can see that, but it is not belonging to Texas, right? So it will not come up in the query. So what you're saying is, find out a customer from customer dimension which does not exist in the order fact, and state is equal to Texas. Now just be careful here, right? I mean, when you are doing this, just make sure that you are putting this out of the bracket, right? And it's not going to work here because anyhow that state is not there, so it's going to give you a query error, right, in the order fact table. But just to make sure that you have, after where you have this subquery, and then you put this condition, right, and state is equal to Texas. Because sometimes what happens is, when you are writing the query never mind a purchase, you forget to put a state, you forget to put a state customer, sorry, state is equal to Texas, right? And that is also being asked. So basically two conditions are asked here. The state is Texas, and then who have never made a purchase, right? So let's just run the query. It should give you the correct answer, right? So customer 5 and Susan Holmes is the customer who is living in Texas but has never made a purchase, right? So this is pretty common actually, right? I mean, if you see, it is basically a subquery concept, and basically join between two tables. You can say it's not exact join, but that's what you have to query another table to find out the matching record, right? So this is pretty common in the first round of the interview, right? And evaluation in the data engineer interview, or BI engineer interview, or even senior BI and senior data engineer interview. These kind of questions can be asked in the first round. So this is basically, I would say, basic to advanced level. I would not call this advanced. It's basic to intermediate level question, right? But it covers the concept of subquery and not in clause and things like that, right? So it is pretty important. This is a probability like 70-80% of time this kind of concept will be covered, right? Okay. Well, let's move on to the second part of it. Okay, the second question. So the second question is, display the total count of customers and their total item spend amount, okay, by country who made their purchase through web and customer service. Okay, so if you see, this is again a classic example of something that we covered in part 13 of series also, right? Part 13 of the series, the previous video, where there are multiple conditions given. So initially, when you see the question, right, it looks to you like a little tough, okay? But like I mentioned in the part 13 also, you need to break down the question, okay? Like that will make it very easy for you. That will make the life very easy, right? I mean, what are they asking in the select clause? What are they asking in the filtering condition? Are they asking any aggregation, right? So total item spend amount, right? Count of customer. So what does that tell you? Aggregation, right? So are they asking any aggregation? Yes, in this case, count and sum, right? Are they asking any group? So obviously, when they are asking for the count and the sum, definitely it should click that it's a group by clause will come, right? Because you have to use, so what are they asking for grouping by, right? They have to ask, right, that group by this. So in this case, by country, right? So what are they asking? They are asking you to group by country, right? And then they are asking, then there is a filter condition, right? Made purchase through web and customer service, right? So like we saw in the order fact table, there is a channel, right, by which customer orders. So they are saying web and customer service. So if you remember, if you see the query of the order fact, right, it has three channels, right? Mobile, web, and customer service, right? So definitely they are not asking you to take a mobile. They are asking you to do only customer service and web, right? So let's just gather this query thing, right? I mean, let's just try and structure this query. So they are saying total count of customers. So where does customer reside? You have customers in order fact table as well as the customer table. But since they are asking by country also, you can get the customer from the customer table, right? So customer is then customer table. Their total item spend amount. Item spend amount, where it is? Is it there in customer dim? Total item spend amount. Yeah. So it's there in customer dim. So that's also going to come out of the customer dim. By country, country is also in customer dim through web and customer service. So web and customer service, where is it? It is in the order fact, right? The channel it was in the order fact, right? So what does that mean? If you have to get to the web and mobile, web and customer service, you have to join, correct? Because otherwise, how are you going to get the channel, right? I mean, order type. So basically, that's where you have to join between two tables. So if you have to join between two tables, what's the common ID? Customer ID, right? So that should click in your mind. So what we can do is first you can see that customer name and order fact you can join using customer ID. And then since they ask for filter condition, immediately put the filter condition, right? And order type in web and customer service. They asked two, right? So you need to use in clause, right? If they have said only web, then is equal to will work. But when they are saying more than one, you need to use the in clause, right? So that's where you will put a filter. Okay, now they ask for the count for the customer count of customers and their total spend by country, right? So here what you will do, you will put c dot country because they are asking you to group by country, and then you will see count of customer ID, right? That's what they are saying, total count of customers and their total item spend. So total item spend and count of customer, you have to do a count of customer, they ask for it, and then you have to sum up the item spend, right? Because if you see, the item spend, you need to sum up the whole amount, right? I mean, they are, because it's not, it's, remember, it's not grouping by customer, it is grouping by country. So in one country you have multiple customers, right? So if you see, if you go and see customer dimension, you have, then they ask for group by US, all these people will come, right? Because they are asking by US as a country group by, right? So it has to sum up all these things, right? And then if Canada is there, you need to sum up these two records. US is there, it has to sum up these two and the other records. And the France, there's only one record, so only one will come. Okay. So let's run the query, right? I mean, so the count we got total spend amount also, and then we need to group by country, right? Because we are using count and sum two functions, right? So we need to use group by along with that. So group by c dot country, right? So when you do that, let's see what's the answer. The answer is France one, right? Is yeah, it was only one customer in France, right? So 1400. US is 6 and 11,000, right? There was Canada also, right? So why Canada did not come? Because I think Canada did not have, if you see customer dimension, right? Let's see customer dimension. Where does Canada? Canada, the customers are 6 and 7. Okay. 6 and 7, right? So we need to go and see whether 6 and 7 had any web or customer service order or not, right? So how do we check 6 and 7? We need to go and check 6 and 7 in the order fact table. Do we have 6 and 7 in order fact table? We don't have 7 in the order fact table, right? It's not there. That customer never placed an order, so it's not there. Now, in the 6, do we have? Yes, 6 we have. But look at the order type. Order type is mobile, right? They ask for order type, customer service, and web, right? So that's why the Canada people are not coming up, because one of them did not place order and one of them did not have a channel like order type as customer service and web, right? So that's why it's not coming. So that's the correct answer, right? So that's how, even though, like you said, like I said, earlier, even though the question looks like a little bit lengthy, but once you structure it in your mind, right? I mean, and once you put the steps, what will come in select clause, what will come in count and sum, right? Group by, right? What do you have to group by and what you need to group by, right? The country is what they are asking for you to group by, and then count of customer and item spend is what they're asking you to group by. Summation of that. That takes care of select clause, overall select and group by clause, right? Because by country and then count and then total amount spent. So that takes care of your country, your group by clause and select clause. In the filter clause, what did they ask for? Filter clause, they are asking for order type, web, and customer service, right? And then in order to get to that filter clause, since it's another table, we have to join the two tables, right? So we join the two tables using customer ID, which is the basically common column between the two tables, right? So if you did that, if you went step by step, select clause, group by clause, from clause, join, what are we going to join on, and what is the filter, the query looked pretty easy, right? I mean, it's simple query. So that's it for it today, guys. I hope this you found very helpful, right? I mean, if it is the case, then please subscribe to my channel and please like my videos. This question also that I covered had covered, like, summation and count function, right? Which are aggregate functions concept. Then you have order type in, which is a filter concept, and then you have an inner join between two tables, and then group by clause, right? So basically we cover, like, two or three concepts. So this is also very common in the first round of interview, right? Usually they do ask either the aggregate function, which is count, sum, and all, or the Windows function, right, which is rank and things like that. So these concepts are very important. Even the first question where you are trying to join the two tables and finding the match between two tables is very common, right? I mean, 70-80% of time these two kind of questions are definitely asked. So just play around with the data. Like I mentioned before, I'll put a create table and insert table scripts in the comment section, and then you can copy, and then you can just run it on the PostgreSQL, and then you should be able to run the queries that I was showing. So thank you guys. See you in the next video. Thanks, everyone. Welcome back to my channel Database SQL. In today's video, I'll continue with the Amazon SQL interview question, and this is going to be part 15. So I have made around 14 videos before this. So and that is all. Everything is in one playlist, which I'm going to put in the comment section. So I do request you guys to please go and look at those 14 videos as well. Those videos also have like very useful questionnaires. So let's get started with today's video. So today's video is mainly focused on self-join concept, because that's also one of the join concept that gets asked frequently in Amazon, like initial rounds, right? I mean, it's whether it's data engineer or BI engineer related interviews in the initial round, right? I mean, these kind of questions are asked, and self-join is a very common kind of a join concept, which frequently gets asked. So I'll just go over a couple of questions that can be asked. Uh, I'm going to use the same two tables that are used in a part 14, right? I mean, so if you have not looked at part 14, I highly recommend that. And I'm going to paste the insert scripts and create table script again in this video, so that even if you have not watched that video, you can still copy paste from the comment section, and then play around with the data and run the same query as I'm running. Uh, Before I get started, right? I mean, I have a request that please subscribe to my channel and like my videos. That's going to give me a lot of encouragement to make new content. So let's get started. So here, if you see, there are two tables that are given. That is customer dim, and so it has the customer information, customer ID, name, birth date, item purchase date, item spent, city, state, and country, and there is a order fact table. So if you look at this table, it has order ID, order 1, 2, 3, 4, 5, 6, 9, 7, 8, 9, 10, 10 orders, and customer ID. So if you see, there is a repeat customer, right? And it's pretty much a common scenario that you see, right? That one customer obviously can place multiple orders. So in this case, if you see customer 1 has placed like order 1 and 8, 2 has placed 2 and 9, and 3 has placed 3 and 10, and customer 4, 6, 8 has only placed one order, right? I mean, and there is an order date, and then order type, like whether the order was done through web, mobile, or customer service. Okay, so the question that they are asking is show those order IDs which are placed by same customers but having different order type, right? So what they are asking for here is show those order IDs. So display is, you need to have order ID which are placed by same customers. So what do you mean by same customers? So same customer means obviously let's say customer 1 has placed the order, so it's the same customer, right? So one customer has placed multiple orders, right? More than one order, but having different order type, right? So what they are saying is, if customer 1 has placed two orders, is their order type different? Web and mobile? Yes, it is. 2 has placed order 2 and 9. Has their customer order type different? No, it's same. And 3 has placed web. So customer type is different? Yes, it is different, customer service, right? So that means our order 1 and 3 should come up in the query, correct? Right? So since they are asking, since here we need to, here it's basically they are trying to trick you, right? So here they gave two tables, but do you really need the customer table? The answer is no, right? Because they're not saying show me the customer name, right? They are saying show me the order IDs and the customers also. So all the information you get it from the same table, right? So when they're trying to ask, like, right, by the same customer having different order type, right? When they're trying to ask this kind of questions, giving you only one table, right? They're trying to compare, right? Placed by same customer. That means you have to compare two customers, right? I mean, the same customer but different order type. So you have to compare the order type, right? So in that case, just it should click in your mind that it's the question is related to self join, right? Self join, right? I mean, otherwise, how will you match the data between two tables? The only way to match the data between two tables is to, like, have two tables, right? And here there is only one table, so you have to create a two tables out of one table, which is basically a self join. You are using the same table two times, correct? So if you see here, first they are asking for order ID, so we need to have order ID, and then do a self join, right? So we are using two tables, and then what we are saying is the question is having different order type, right? So that means the table A order type should not match to table B order type, correct? It's pretty straightforward, right? Yep. And then placed by the same customer, right? They are saying placed by the same customer. So that means customer ID has to match, but order type does not have to match, correct? Right? And then the order ID, we need to put this condition in self join because order ID should not match, right? I mean, order ID should be different, correct? Because if you are not going to put this condition, it's going to match the order IDs also, right? So we want different orders, right? We want separate orders, different orders placed by same customer, but having different order type, correct? So when you run this query, right? So as you can see, 1, 3, 8, and 10, right? Those are coming up. So 1, 3, 8, and 10. So if you see 1, 3, 8, and 10, correct? Because customer ID placed two orders, both are having different order type, correct? And then 3 is customer service, order 3, and 10 is web and customer service, right? So that means we are correct? We are showing the correct order IDs, right? That means our answer is correct. Now, let's say they asked that show me those order IDs which are placed by same customer but having the same order type, right? If they ask this kind of a question, same order type, that means what you will do here? You will say equal to instead of not equal to, correct? So when you do that, what do you get? 2 and 9, right? Why? Because as we saw, 2 and 9 is placed by customer 2, if you remember, right? 2 and 9, order 2 and 9 is placed by customer 2. And why it has come up? Because web, right? There is only this customer, right, which is having the same order type, right? Web. That's why it's coming up, right? So just read the question properly, right? I mean, and then based on that, just frame the question in your mind, like I'm saying in other videos also. Try and frame the question first. See whether you need to use self join or you need to join two tables, right? Join condition first, look at that, and then see what needs to go in select clause. Is there any filtering condition they're asking for? Is there any matching condition they're asking for, right? So based on that, just format your query, and then when you see we wrote not matching order type, same customer, right? And order ID obviously has to be different, right? So that makes it forming of query very easy. Okay, so that's question 3. Question 4 is the reason why I have question 3 and question 4 is because question 1 and 2 is covered in the part 14, right? I mean, because it's the same table, so instead of having question 1 and 2, I'm just continuing that series, right? I mean that part 14. Question 1 and 2 is covered in part 14. Question 3 and 4 is covered here. So that's why I'm saying that I highly recommend you at least look at part 14 if you are looking at part 15 first, but I recommend to look at part 14 first. Okay. The question number 4 is show those customer IDs by month of order date who placed the order in same month and year okay, you placed the order in same month and year. Display the actual order date also along with the customer ID and month of order date. Okay, so here they are saying display the actual order date, okay, along with the customer ID and month of order date, right? So first we need to see where is this information available. Okay, here if you see they are saying customer order date is available here, right? Customer ID is available here, and month of the order date. So month is basically extracting from order date. So here also again you don't need to go to the customer table because they're asking customer ID, right? Again, you don't need to go. You need to just use one table and show those customer IDs by month of order date, right? Who placed the order in same month and year. Okay, so what they are saying is the order should be placed in the same month and year. So let's see. So you have customer ID 1 and 2. Is this matching? No, because month is different. Here also it is not matching, right? So 22 4 10. Do we have 22 4? Yeah, see, this should come up, right? 6 and 3 because they placed the order in the same month, correct? 10 4 and 16 4 and 2022, correct? Yeah, and then 12 4 also. Okay, it's the same month, right? So it should come up. So these three should come up, as well as you have in May, you have May 2022, you have three orders, right? So basically what we are saying here is 2021 is not matching, 2022 February also not matching, 3 also not matching. So basically what we're saying, in April there are 3 orders, and then in May there are 3 orders, correct? That should be our answer, correct? So uh, in the query, right, again since we have to use the same table, right, we need to use the self join, correct? So what we are going to do here is we are going to say distinct customer ID. Then there is a they are saying by month, right? They're saying by month of order date, right? So how to do the month? You need to have a function in Postgres. You need to write that function, say extract month from order date. So this is the function that you need to use if you want to extract month from the order date, right? If you want to extract year from the order date, you need to put year. Okay. So that's how the Postgres function is structured. Okay. So you need to put extract month from order date as month of order date and then order date, right? They're asking you from order fact A and fact B, right? Again, the order ID should not match, right? Because they are saying, right, that customer ID who basically placed the order in the same month and year. So you need to make sure that there are 2 different orders being placed in the same month, right? That's why you need to put this condition, okay? And again, the customer ID should not match, right? Because we need to have unique customer IDs, right? That's why we are saying distinct, right? So the customer IDs, we want those different customers who have placed the order in the same month, correct? That's the ask, right? And then what we need to say, and because they are saying placed the order, who placed the order in the same month and year, right? So that's a filter condition, right? So we need to say extract year from order date is equal to extract year from B order. So if you see this, we use 2 tables, right? So we are trying to match the order date between 2 tables, year of the order date and month of order date, right? Because you need to match that, right? Because they're saying same month and year. So how will you make sure that you will make sure that by matching the year and month of order date from the both tables, right? That's how you will get the same matching order month and year, right? So let's run this query. Okay, so if you see, right, it is coming up correctly like we envisioned, correct? So in May month you have 3 orders, right? And then in April month you have 3 orders, right? So it's showing customer ID, it's showing month of order date, it's showing the actual order date as well, right? So that's the answer, right? I mean, so again here, first look at whether how many tables you have to use, whether you have to use both tables. In this case, no, you have to use only one table. Then if one table, they're asking you to do the matching condition, right? That those customer by the month of order date who placed the order in the same month and year, right? So you need to use the self join, and then once you know that it's self join, then you need to determine the joining condition, right? So obviously order ID placed the 2 different orders in the same month, right? So order ID should not match, even customer ID should not match, right? It should be placed by different customers, right? And then filter condition is given that the month and year of the order should be same, correct? So that's why we put a filtering condition also, right? So that's our answer. So overall, if you see, right, both these questions are covering the self join concept, right? It's covering the self join concept. It's covering how to extract month and year from the order date, right? So I hope this video was useful to you guys. And if that's the case, I again request you to please subscribe to my channel and like my videos. Thanks, guys.